Well, welcome to this session inside Tempdb. Thanks for your participation here at the PASS conference. I'm not sure it's a good idea to have me go after lunch. You guys may be snoozing at the end of 3 hours. My name is Bob Ward. I'm a principal architect escalation engineer. That's a mouthful from Microsoft. If you've seen me talk before, that just means it's been a long time. It seems like every year I speak, there's another part of my title that gets added. I did put my email address on here. This is not an open forum for emailing me on anything. Really what this is for is if there's a question today that we don't answer at the end of the talk, if there's a question that you don't answer for me at the conference, I'm happy to address your questions about Tempdb after a couple of weeks after the conference or something like that. So let's kick in and get started. This is 3 hours. If you did not realize this is a 3-hour session and want to get up and leave, you're not going to offend me, okay? There will be a break. I think your mind and my mind will need one. So we'll do it around 2:50, which still gives you time, I think, to get the refreshment stuff. But we will only do it for 10 minutes. We'll come right back at 3 o'clock because there's so much stuff to go over and we need time for questions at the end. So there'll be a break at 2:50. Hopefully most of you will come back after that break because you're not so either bored or uninterested in this topic. I'm going to warn you some stuff about this talk. Hopefully you got enough when you read the abstract on the website about this session. This is not a talk about best practices, design, or managing. There are a billion pieces of information out there from blogs and white papers and various resources about best practices and designs of Tempdb for your application. This is a very internals talk. This is kind of how it works. But I hope you're going to get some stuff out of this today. I hope you're going to find about learning more how it works is going to help you make decisions about your application. So this is a 500 level talk. People have asked me before, what does that mean? All it means is I bring up the debugger every time I speak. That's it. So I will bring up the debugger actually a couple of times. So no, actually it's a very internally focused talk. And you may not think it's 500 when I'm done with this. But we are going to dive into some of the internals of the product that you just don't normally see. And so that's why I always want to put on a note that it's kind of a 500 level session. And then the last warning is that be really careful here. There is some undocumented information I'm going to go over to present this internals for you. And if you see something or I point out this is undocumented, I don't want you to rely on your app for that. I don't want you to rely on some of the things that are not documented to say, oh, it'll never change. So just be careful when you see those kind of things in the talk. And then last of all, when you see the little guy pulling a little rabbit out of his hat, that's demo time. That's where I'm going to flip over from a slide and actually try to show you some stuff of the product. Okay, real quickly about CSS's representation at PASS. Monday, Adam Saxon did a pre-con on Kerberos. I'm here speaking today. Also, Adam is speaking on RS later today. And then Cindy Gross from our PFE team is going to be speaking tomorrow. And then finally on Friday, Keith Elmore and Boris are going to present things on dashboard reports. So CSS has a great representation at the conference. This is really important though. Room 611 is what we call the SQL Server Clinic, where members of the CSS team like myself and the CAT team will be there to answer your questions. I am there after this session for the rest of the day, and then I'm there all day tomorrow. Well, there is this thing called the American League Championship Series going on, and my team, the Rangers, are in it. So there's a possibility tomorrow afternoon I might take a slight break there from the clinic. I might get sick in the afternoon a little bit. And in fact, my understanding is the game may be going on right now. Nobody yell out the score, please, especially if the Rangers are losing. Okay, first of all, do you want to know whether you're crazy or not? I have this thing called a crazy scale. And the first answer is, you knew this was a 500 level talk, but you came anyways, okay? You're kind of slightly crazy. Second of all, you knew it was 3 hours, but you still decided to show up. You said, all right, it's 3 hours, it's really internal, but I'm still going to be here, right? You posted on Twitter that you were going to attend, you were looking forward to the Bob Ward session. And you've actually been to one of my sessions before. So you're really further up on the crazy scale, right? You actually skipped lunch to get a front row seat here, and that's really crazy. I mean, look at all the seats that are here in this room, right? You actually think you have a chance of understanding this. Now, you're really getting nuts now. And then afterwards, you actually do understand this, and you're excited about it. Then you're really crazy. And finally, you've reached the most part of the crazy scale if Microsoft wants to hire you. Because if you've done all that, come up front. If you actually get this stuff, I want to hire you. Okay, so I'm sure this is why you're all here, right? How many people want to know the answer to this question? How many files do I need for Tempdb? That's why you came. The answer is Near the end of the talk, of course. I'm not going to tell you now. Was that booze I heard? Booze in the audience? We will talk about this. I actually saw a little benchmark I did in this topic. So, all right, let's get into the session a little bit. Why Tempdb? Why did even you choose this type of topic? Well, there's a lot of misinformation out there, in my opinion. Not necessarily about best practices in design, about how it works. And so that's what we're focused on today. Since I've been at Microsoft for almost 20 years, this has been a customer pain point. So since the days of 4.x, this has been a problem and a lot of issues from customers. So I thought it was important maybe this year to pick that topic. And then who doesn't use Tempdb? I mean, every app out there using SQL Server in one way or fashion or another uses Tempdb. And then everybody I talked to, I said, hey, what do you think about a Tempdb talk? They're like, yes, please, do a Tempdb talk. That would be great. So, it kind of made sense maybe this year to have this inside series that I do each year at PASS to be on this subject. How are we going to do 3 hours of this? Well, we're going to first talk about the creation of Tempdb, some of the internals of how it's created. We're going to go into a little more depth of the internals of logging. Yes, there is a transaction log for Tempdb, and it is needed, and I'll show you why. And then we're going to do a little tour of some of the different objects that go in Tempdbs, maybe some details about those objects you didn't know about. And then absolutely, we'll focus a lot of our time on allocation, the internals of actually how the allocation algorithm works, especially when it comes to multiple files. And then this isn't, again, a managing, even a troubleshooting stuff, but being in CSS, I've got some specific comments at the end of the talk about managing and troubleshooting and things about Tempdb. And then we'll have some time for questions. Hopefully we'll have some time for questions. Again, if that doesn't happen, if for some reason I just have all this stuff I'm showing you, and there's like 5 minutes left, and the next speaker's here, I will stand out there in that hallway until like dark if you want, answering questions about Tempdb. I'll be at the clinic all day tomorrow, and you can send me an email about it as well. And so somewhere around the objects unleashed is probably the breaking point. This is when you are probably at a breaking point. Well, you'll get a little bit of a break for 10 minutes. And then hopefully at the very end, you won't have to be carried off. Because some people have said in my sessions before, they need to be carried off. Okay, what's different about Tempdb? Well, it's often used implicitly. A lot of the cases I see from customers are about creation of temp tables that they explicitly do. But a lot of things I see where customers don't understand how Tempdb works is because it's implicitly used, and we'll talk about that. It's a very heavily used shared resource. It is one of the most heavily used shared resources in the engine because it is a shared database that all applications use, regardless of what database context they're in. We, Microsoft, have chosen to dump just about everything we can think of in there. And I spent a lot of time preparing for this talk, looking at our source code, looking at examples, and give you a feel of all the types of things we're putting in Tempdb. And then it's volatile. Obviously, with each restart, we reset everything that does with Tempdb, we recreate it. And the logging's different. And we're going to get into the internals of how logging works. And everyone hates it. Everyone I talk to hates this topic. And then finally, of course, no one gets it. No one understands it. So that's what's unique about Tempdb. Let's talk about the creation, what I call the birth of Tempdb. Okay? Right after we open the master database, we go through and we do this process of creating Tempdb. And the very first thing we do, as you may have kind of seen or read it before, is we open model. We open the model database. And then we create Tempdb based on model and its properties. We have to notify the rest of the engine that Tempdb is ready. And then if we fail in any of this process, we have to shut the server down. Because we consider Tempdb a critical resource to use for shared in the engine, and therefore we don't want to keep the server running if we can't create it. So that's kind of the overall algorithm. It may be similar. That may be something you already know. It's like, oh, I get that. That's pretty easy. That's not 500 level. What is he talking about? Well, let's get a little more 500 level. Okay? There's a little hat guy, so we'll do a little small demo here. So how do we actually do this? How do we make this happen? So the first thing you do is we lock model in Tempdb. Okay? So connections at this point are allowed into the engine. But we don't want anybody to use model in Tempdb while we're doing this. So people can come in and get connected because master's already going. And user databases have started to recover, but we don't want to let people get into these databases because we're still trying to create them, so we actually lock them both. Then we go into the process of actually creating the database. We create the primary database file based on the properties of master, and then the algorithm gets interesting. What we end up doing is we end up copying one extent at a time, literally, information in the model database into Tempdb. And this includes any objects that you put in model. So if you created user objects in model, we're going to copy those all into Tempdb. Then we're going to take the primary file and we're going to fix it up. In other words, since Tempdb was created first from the model file, and if you had configured Tempdb bigger, we're going to have to actually go increase the size of Tempdb. Then we create the primary transaction log file, and then what's kind of unique about how we do Tempdb, we then go create and attach all the other secondary files. Now, I pointed out SQL Pool Boy. I don't know if he's in the audience, but that's Jonathan, one of our famous MVPs. He came to me with an interesting bug about a year ago, where if you create a really large user table and model, and then you try to go create a new database, you'll actually create a corruption problem. So, and actually, it does actually affect Tempdb because we're still copying all those extents, but it doesn't cause Tempdb not to start, and it requires like some 4 or 5 gigabyte table to create to cause this problem. And so finally, if you have issues with creating Tempdb, you may have seen this parameter -f or minimal start with Tempdb, and this is where we go in the process of only building one primary data file, the size of model, and we set it to unlimited fixed autogrow. We build a specific primary log with that type of byte number. And the reason it's that byte number is because it's just enough log to hold two virtual log files, including a log file header. And then I've got calculation in the note slides of exactly how much why it is it being that amount of bytes. And then we put it in the default data folder. So just to avoid any problems, we put it in the default data folder. And then the original sizes you created, of course, are retained. So when you restart SQL Server after fixing whatever problem you had, you can then restart with the original sizes. And one point I thought I would point out here in this talk today, I did some research. There's not a lot of changes in Tempdb for Denali in the new release of SQL coming out. So I don't have a set of slides on Tempdb and Denali because, quite frankly, I couldn't find a lot of differences in what we've done. But one thing I did find that affects Tempdb is the default size of model, which is now 4 megabytes. So it used to be 2 megabytes. So I thought I'd point that out. Let me flip over and show you a couple things. Okay. So first, I just want to show you the error log file. I didn't check my font size for this one. I may have to increase it. Yeah, let's do that. Is that better in the back? Yeah, I thought so. Okay. So you may have seen this database before. When you see this message right here, let me back up. Here is starting database model. See that? Okay, that's where we're opening up model, getting ready to create Tempdb. So once we open up model, we go through that process of locking it. This clearing Tempdb database entry, that is the process of actually copying the extents, creating the primary file, and creating the primary log file. So when you see this clearing temp database, you'll know we're in that process now of actually building Tempdb. And then when you get down to the point of recovery, here's the starting up of Tempdb. So when you see clearing Tempdb and starting Tempdb, the difference between them is the time I just told you we actually had to create to get it going. The starting up Tempdb process is when we start actually creating and attaching the secondary files. So if you're ever looking at your error log and want to know the sequence of phases of what's started, what's next, and what's next after that, you can just look at these messages to get a feel. And if you saw a major amount of time between this message, clearing temp database, I apologize for the noise, I'm not sure what that is, and starting up Tempdb, you would know that there's some sort of long period of time of something going on, creating probably the log file or copying the model file. Maybe model was just expanded to be some of this massive size and had a lot of user objects in it, then that would cause us to take a long period of time there. So that's one thing about just looking at the process of what's in the log file. Now, just to kind of prove my point that it's just a copy of model, I thought I'd show you a couple of pages. So I just grabbed page 100, which I know is in both databases. So there's my model, there's my Tempdb. Just using DBCC page, I can dump out the contents of these pages. And just looking at the header, I can see that these pages are identical. You scroll down here, here's the header here. In fact, what I'll do is I'll do this. Kind of like this feature of Management Studio where I get to do that. So I can look at these two pages, and you can see that they're actually an identical page. In fact, it turns out this is an IM page. So this is just showing you an example of how we've actually copied literally one extent at a time. It's just literally a file copy operation that goes on when we first start Tempdb and model up. So let me show you another example when you have a problem creating Tempdb. Okay, so if I go here, and let's say I come into Tempdb, and I bring up the file property, and this is in megabytes, right? So if I want to create this to 120 gig, what number do I put in? How many? So 120,000. So here's 100. That right? That was not right. That was right, actually. Okay, so that was 120 gig, but look how fast that happened. That was quick. Do you let me know why it happened so fast? Instant file association, right? Okay, that's very good. Very impressed. So if I go over here, first of all, if I shut down SQL Server, you go back to this directory here. There's my large Tempdb file. Now, what if I did this? If I rename it to this, if I go here and say, okay, and then I try to start SQL Server. Okay, that didn't work as I thought it did. I must have enough disk space. Actually, it didn't work. So if you look here, notice that in the clearing Tempdb database statement, this is when I'm trying to create Tempdb, right? I go here and I have a problem with creating that primary file. And notice the message I get here, right here. There's not enough disk space. So if you ever run into a scenario where SQL Server does not start and you see these sequence of messages, you can see just from the errors alone that this is a problem just because I can't create Tempdb because I run out of disk space. Now, if you run into this scenario and you're like, what do I do now? There's a couple things you could do. The number one thing you could do very easily is you could start with -f. Like that. Okay, now it works. Now if I go in the error log here now, I actually can see it starting up Tempdb actually works, recovery is complete. If you go into your catalog views, let's see here which I want. Now, if you go into sysmaster files and look at Tempdb, you see, remember the overflow. I didn't even have this calculation set up right. That is the actual size of what we have Tempdb configured for, right? But since I use -f, if I go to just the database files of Tempdb, I can see that it's 3 and the log is even less than a meg. So with -f, I can get the server running very quickly and solve my problem. In this particular case, it's because of the fact that I just renamed this file. And so if I go back in here, and I delete this back file, now this is an interesting scenario here. I've deleted the back file, okay, and now I've got to restart SQL Server. What do you think is going to happen? Yeah, it's going to create Tempdb again, and the file doesn't exist actually. Before I do that, let me go to the next slide because I jumped ahead of myself a little bit. I created the next demo without realizing it. But you see it here now, -f could be used in the case where I can't create Tempdb, but I still retain the original size. Okay, so in this particular case, before Tempdb is ready, we can't allow anyone to use it because connections are already allowed. Should they wait or should they fail? Well, in this particular case, what's going to happen is connections are going to wait. Because anybody coming in trying to use Tempdb is going to try to acquire a database lock on Tempdb. But remember, I told you you've already locked it when we were trying to actually create it. So when we actually create model in Tempdb, we put exclusive locks on them, so nobody can come in and actually even use the database at all. Recovery completed, the actual message that says recovery completed, that particular message is not going to actually happen until Tempdb is actually started. So we wait for all the user databases to recover, and then the thread that's actually going to print recovery completed, it tries to actually get a lock on Tempdb as well. So if Tempdb is not ready, it's going to wait. Now this is the part that's interesting. If you have existing files on the disk, creating these things can be very, very fast, okay? Provided that the existing size is greater than the new size, okay? If the new size is greater than the existing size, we'll have to zero it out, potentially, like in the case of the log. For instant file initialization, that's not the case. But for the transaction log, that could be an issue. And so for the T-log, we must zero out new files. So in the case what I just showed you, Tempdb database couldn't be created, but because of instant file initialization, that should come up very, very quickly. But the log might be a different case, and let's look at that. Okay. Let's go ahead and start the server back. I'll start and restart it. Oops. And you see it came in very quickly. Even though it's a very large size at this point, it came in very fast, right? If I go in here and I look at Tempdb, and I look at the size of the file, look, you see I now retain still that size. What if I try to go create a fairly large Tempdb log file? How about this to be 5,000? Now it's taking some time. Now this is because for the transaction log, we don't support instant file initialization. So it's got to zero out the entire log. Now, the interesting part, though, is if the log itself already exists for Tempdb when we first create it, we don't have to zero out the whole entire log again. We just have to zero out some of the records that matter for the first virtual log files. So once this already exists, you're fine. If you delete it, though, and we have to recreate it, we have to zero out the entire thing just like we're doing right now. So let me show you kind of what this looks like. And I got to warn you that when I bring this back up, we are going to use the debugger. So get your debugging hats ready when this finishes right here. So. Okay. Let me come back over here. Let me load up some of these queries we're going to run to take a look at this scenario. We are going to run this one. Here we go. Let's load this guy. Because I want you to see the specific sequence here. We'll load this guy. We're actually going to disconnect Object Explorer for a very good reason. This guy is still creating. So what I'm going to end up doing here is that when we restart SQL Server, we're going to delete the log. We're going to start bringing up SQL Server. We're going to show you the sequence if I tell you about the fact we have to wait for people to come and use the database because they're waiting on database locks. Okay, this is finished now. So if we go back over here, and I go ahead and delete my log after I stop SQL Server. Okay, now if I start it again, let's get our debug script ready over here. Okay, that's ready to go. Now if I go off and fire this query right here to create a table, he's going to wait. And if I go and I say connect Object Explorer, he's going to wait too. Now if I go over here to this window, and let's look at the waiters that have occurred here. Okay, in this particular case, let me go ahead and get the debugger up. Didn't retain my font size. I don't know why. So you can see that in the back. Now, if you look at this output here, let's pay special attention to this. If I look down here, I've got a background task that says DB startup, and it's got a wait type of IO completion. Then I've got another background task here that says unknown token doing preemptive OS write file gather. And then I've got a couple of guys that are suspended. I've got a create table statement that's suspended. He's suspended on what? He's suspended on a lock, and that happens to be a database lock for Tempdb. So the create temp table statement here is suspended. The select statement here, this is from the Object Explorer trying to connect. He's also suspended. Because again, they tried to go and use Tempdb and they couldn't. We're still trying to create it. And you can see here that this 16 is blocked by 51, and 11, this is blocked by 11. 11 is the task that's doing IO completion. Now you're probably asking yourself, well, how come it's not blocked by this preemptive OS write file gather? Preemptive OS write file gather, that's the guy zeroing out the log. And I'll show you in the debugger exactly why this sequence occurs. So I'm going to use a debugger command called bang unique stack, which just dumps all the thread stacks in the engine. Except it does it only for the unique stack. So any duplicate, like all the worker threads that are idle, won't show up for me. So if I look at this sequence here, I can tell, if you remember from my wait type talk, you can see here that in this particular case, here was a guy trying to do a create table, and he is waiting on a lock. That's the guy waiting just on a database lock. Notice it says OpenDB. That's because I'm trying to open Tempdb. So I'm waiting on a database lock here. That's what that thread's doing. If I go a little further here, this is one that's doing, actually, notice the write file gather. That's the preemptive OS write file gather thread. That's a guy zeroing out the log file. And notice here, down lower in this call stack, it says system thread. That's an indication whenever you're looking at these call stacks in the debugger that this is a background task. If it says system thread, he's been dispatched to go out and zero the log. If you look a little further here, you'll notice this guy started out by doing a select statement right here. He's doing a query, but one thing's interesting about his query. He wants to go out there and do something called create work row set. As we're going to find out later in the talk, that's an example of doing a work table. Okay? He's trying to do an actual work table, and if you look below her, you can see the word spool. So this is an example of somebody doing a query that needs what's called a spool operator that needs to go to Tempdb for disk. And so he creates this work table. Well, he's stuck because he's trying to open up Tempdb, trying to do it. So that's actually Object Explorer behind the scenes running a query. And then last but not least, this guy here, asynchronous disk pull wait until done. Notice this where it says DB manager start Tempdb, startup start model in Tempdb. That is the thread that prints out the word clearing Tempdb. So the sequence is he prints out clearing Tempdb. He goes off and requests another thread to actually go zero out create the log file, which has to go zero out this log. Meanwhile, the other guys are stuck waiting on a lock of Tempdb because this guy right here is the one that owns that lock. He actually goes and owns that database lock for Tempdb. Now everybody's blocked. So this is just an example where this is something I would do in my job. I would look at the sequence here if somebody called me and said, okay, give me a user dump. And I would look at the sequence and figure out who's waiting on who just by looking at these call stacks. Okay. Always use the word detach when using a debugger. If you use quit, you're going to kill the process. Okay, did these guys ever finish? They're still waiting. I'm just going to cancel him. Okay. The question is, can you use this together with SQL Dumper? SQL Dumper just produces stack dumps on demand, and behind the scenes, it's a program that produces stack dumps for access violations and various things in the server. In this particular case, I just attached live with a debugger. But you could see this from creating a dump file. Yeah, you could use a dump file to see the same information. Okay. Let's talk about the Tempdb transaction log, because a lot of myths and I think misunderstandings about how it actually works. Because I have a lot of people say, oh, Tempdb doesn't do any logging, or Tempdb doesn't need a log, or we do minimal logging. What does minimal mean? And so I thought it'd be interesting for you to know a little more clarification on the details of this. So first of all, we do minimize logging. And one specific example is what I call after images for inserts and updates. And I'll show you an example in the next slide of exactly what I mean. It only applies to heaps, which a lot of temp tables are heaps, but we actually minimize what we have to record in the transaction log for certain types of operations to help minimize its size. Now, Tempdb is really a simple recovery database, even though it's not technically a simple recovery database. And what I mean by that is that when there are places in the code where we make decisions for simple recovery databases, we have something we say, or if Tempdb. We have specific logic to handle Tempdb like a simple database. And what's different about than simple databases is that there is no need for crash or media recovery. So if you understand what I mean by that is that who cares if SQL Server crashes and you lose Tempdb? It's a temporary database. So we make specific decisions on what we log because we don't care whether SQL Server crashes and you have to recover anything. Second of all, you don't have any media recovery in Tempdb, so we can make decisions that way as well. So then, why do we even have a transaction log? I had that question asked before. Does anybody know the answer to that question? Why do you need a transaction log for Tempdb? If you don't care whether you do crash or media recovery, why do you need one? I'll be really impressed if somebody knows the answer to that question. Rollback. It's all about rollback. It is about ACID properties, but it's not about redoing things. There's no such need for that. It's all about rolling back. Our code uses rollback, uses the transaction log to actually do rollback. So you have to have a transaction log in order to support rollback. And you have temporary tables that have that need. Okay? Internal objects don't have that need, but temporary objects that you create have that need. Okay. Some things you probably don't know about the log, though, in Tempdb. It's a lot faster than you think. We have something called lazy commits with Tempdb. In other words, we don't actually write out the log file. Okay? We do not write out the log file to disk before we flush the pages to disk, because we don't care about crash recovery. So you don't have to worry about it. So when you come along and you actually commit a transaction in Tempdb for, let's say, a temporary table, and you do a commit tran or an implicitly commit tran to an insert, we don't have to write up the log records. And you're going to see some interesting data here in a second about the speed of it. We don't have normal checkpointing of pages. When the checkpoint process kicks in for databases, it just skips Tempdb. It doesn't even try to checkpoint them. Again, one of the reasons for checkpoint is to speed up recovery, but we don't do recovery in Tempdb, so why even waste the time? Now, we support hard checkpoint, though, for Tempdb, like if you run the command checkpoint, but be careful, since we don't do checkpoint, that could take a while. Now, lazy writer is fully supported for Tempdb if it needs to free up buffers that are from that database, but checkpointing is not supported or not even needed. But the checkpoint process does truncate the Tempdb log, just like simple databases. And then most importantly, as you're going to see throughout the talk, these things that we call internal objects mostly just do allocation logging. There's really no property of having to allocate specific transactions involved in these internal objects. And in some cases, we don't do any logging at all. So we minimize the logging needed for temporary tables that you create. We write the log much faster than we do for a user database because we don't actually commit it. We don't write it during commits. And then for internal objects, it's mostly all about allocation logging. So let's show you a couple things. Okay. So a couple little demos here to show you. Okay, I've already got a database created for this guy. And I do want to expand the temp. Actually, my log is, let's see, I don't know if my log is big enough. Yeah, it is, okay. Let me restart SQL to pick up that. By the way, if you're not a PowerShell, if you are a PowerShell user, and if you don't know about this handy little trick here, you can easily restart your service by just typing in restart-service. For SQL, you need -force because there's dependent services, and you just run it, and it does it. That's kind of handy. I like that. I'm a command line guy, so I do this all the time when I'm just restarting SQL. So I just restarted it right there. I'm done. So let me load up perfmon counters because I want you to see this. Okay. So I've got specific counters here for a couple of databases that I own. One called Rangers World Champions. Hey, it could happen. If there are any Tigers fans out here, I'm sorry. And then you have Tempdb. So I've got log-specific type counters for these two databases. Now let me bring up my Rangers. So in this particular case, I'm creating a table, and I'm going to insert 100,000 records into this database. So I've got another one here I'm going to load up. Exact same schema. So same schema. Notice, and I don't know if you know this trick or not, but if you want to create tables that are fairly large and take up certain, guarantee they take up a page or half a page, just create a character column, not null, with a certain value, and you've got yourself a fairly large table, right? So I've got these two different tables, and let me go run the Rangers insert first. As I run that, I will look over here, and I'm looking at these counters here. And if I look at these counters, let me zoom in on some of this stuff, you notice that log bytes flushed and log flushes is fairly high. Actually, let me go back to the log bytes flush. That's the one that really you can see it. If you can see here, log bytes flush is kind of like pretty high for this database, right? And if I let this go, this should take, I think it takes about a minute or something to run. This should be a simple recovery database, so at some point it actually needs to do truncations. But if you clearly, I'm sitting here hammering the transaction log. And why am I doing that? Because for each insert, I have to actually go flush log records because each insert is a commit transaction, right? So I still have log flushes. I'm still running along here. And it's taking longer than I thought I did when I first built this demo. Much longer. I'll stop it because I thought it took like a minute. That's okay, because the next one's going to be really fast. So here's old Tempdb. I drop a temporary table, I create a temp table, do 100,000 inserts, right? I go here and look at Tempdb, and what do I get? I do get, if you go here and look at the counters, I got an initial set of log flushes, and then I don't have anything. Now, the log flushes I had initially were for the create table, but it's still lazily done. If you look at here, the counters are reading almost nothing. And it happened very, very quickly. If I look back over, I'm like, why did it happen so quick? If you notice, it's already finished. It took 5 seconds. So the same schema from a user table and a temporary table, one was taking well over a minute, one took 5 seconds. That's all log right there. It's all about logging. That's why it's that quicker. Not only does that work for this temporary table, but if I tried to go take this user table over here and do this, use Tempdb, and do that, how long does it take? No, 9 seconds. Why? It's a user table. It's not even a temporary table. Does anybody know why? Because it's in Tempdb. I just told you the properties of Tempdb. So a user table can run hundreds of times faster in Tempdb because of our logging properties. But would you ever want to do this? Not if you care about the data. So we don't really distinguish between a user table and a temporary table in this case because it's all about logging. But no one want to do this because we don't support crash and media recovery, right? But I thought you might find that interesting, that you can just simply take a user. Now, it took 9 seconds because for a user table, there are some slightly more logged operations than for a actual temporary table. Not a lot, but some, and that's why it takes a little bit longer, but 9 seconds versus well over a minute is pretty amazing. What's that? The question is that was the database in full recovery? And the answer is no. This database, Rangers World Champions, which will happen this year, is in simple recovery. So it's not a full recovery database. You have a question right there. The question is, what do I think by row inserts in Tempdb versus bulk insert? I mean, it's all about logging, right? So there are similar logged records for this user table as there are in the user database. Just same thing for a bulk insert. Okay, the log records are the same for the user table. The difference is that we don't flush it to disk. So who cares? It'll be much faster. Okay, let me move on. Okay. Now, just to emphasize a little bit about this after image example I'm talking about, I want to kind of show you kind of what I mean by a visualization. So assume I have a table with a row on there with a value of 1, my simple little page in memory here, right? When I go do an update of a user table and I put a log record in there, I have to store the after image and the before image, right? To support both redo and undo. And then actually when I do a rollback, I actually write out what I rolled it back to. So that's what a log record looks like. Now for a value of an integer, who cares? It's a couple of bytes. It's not a big deal. When I go to a temporary table, though, this is what it looks like. If I do an update to a temporary table and set this to 0, I don't have to record that after value anymore. Because for rollback, I just got to know how to roll it back to 1. I don't care about the 0 part because I don't have to do redo. So in the case when doing rollback, I don't actually put anything in there. I just record the fact that I did a modification. Because when we just roll back, we just have to record the fact that we did the rollback. That's all we have to do. So it's all about the fact that there is no redo for Tempdb. Now imagine if these modifications were for very large records, and a lot of them. So you can see that the amount of log space I need between these two may be significant. And in fact, in some of the demos that when you look at my notes slides and you see them, you can run some of them. In that same type of query that I ran, Rangers versus Tempdb, the difference in the amount of log was staggering. It took, in some cases, it could take up to 50 meg of log to do the Rangers one, but only 4 meg of log to do the Tempdb one. So that's a significant amount of space it takes to reduce your transactional size. This may make an impact for you on deciding on how to appropriate the size of the log, and the fact that it takes considerably less space to actually use it than it does for your user database. Now, one thing I did want to show you is the fact that if you fail rollback in Tempdb, well, let me ask this question first. When you fail a rollback in a user database, do you know what the server does or what the behavior is? What's the answer? Oh, it was somebody way out in the hallway. Does somebody know out there? Does anybody know? You do a rollback, and for whatever reason, some catastrophic problem occurs. You're so out of space that we can't even support the rollback, which can happen. What we do in the engine is that we take your database offline because we couldn't support your rollback. So we can't make things consistent. So we actually take the database offline and run recovery for you to make things consistent. Well, we don't do that for Tempdb. We don't run recovery. So what do? We shut the server down. Let me show you what that looks like. And I'll tell you how I did it. Oops. You see this file that says tempdb log 10k assert? I found a bug when I did this. So I put the tempdb log at 10k. That's the size I actually put it at. It allowed me to do it. And I actually ran a rollback of a transaction, and I got an assertion in the server. It blew up on me. So that's a good one to go file. I'm not sure that the devs are going to be happy with me creating a 10k log, but here's what happens with a much smaller log. I created a much smaller log and did a fairly large rollback, and this is what it looks like. And if you look here, you can see the error sequence. I got a 9002 indicating that the Tempdb is full. Then I got and this is you read this kind of going this way. So I got this error 3314 because I couldn't undo a logged operation in Tempdb because of the fact that it was full. And then I got this special message 3449. Server must be shut down to recover this database. This is either a user database that could not be shut down or a system database like Tempdb. So if you were ever to catch this, you would know that, well, I'm really so out of space in Tempdb I couldn't even roll back. So we don't have a choice here. We can't run recovery in Tempdb. It's not possible because of the way we log things, right? So it's not consistent for you to use. We have to shut the server down. There's no option for us. And I've actually seen this in an actual case. But if you want to create this yourself, it's pretty simple. Create yourself a very small log, then go to a fairly large modification, and then try to roll it back, and then you're done at that point. So, yeah. There's two questions I heard. Oops. Is what documented in the BOL? That the server would crash? No. It's documented in my BOL. No, it's not. We don't document that if the server runs out of space for Tempdb or a rollback fails. In fact, we don't even document the fact that if a rollback fails for a user database, that will take it offline and run recovery. I'm not aware of that in our documentation, but certainly not for this. Somebody else had a question? You'll have to stand up and shout it because I can't hear you. I'm sorry, I still can't hear you. No. Just come up here to the front and ask. It's fine. You really want to embarrass yourself and come up front? Is that? That's why rollback failed. So what happened in this particular case is the original log record could fit. So it's a scenario where we actually, in the server, we actually keep in a set of an emergency space available in the log for these scenarios, but I squeezed it so bad it didn't have room for that. So there was enough log space for the original transaction, but not enough space to roll it back. So. That's just the way the server's designed, that when a rollback occurs, we have to write a modification record to roll it back, even for the case of Tempdb. Okay. Yeah, we reserve space for rollback. We do that, but I squeezed it so tight that even that was depleted to support the original insert. So, okay, so let's switch gears a little bit and let's talk about the garbage dump of the engine, which is Tempdb. And I've got a laundry list of things to show you why it's the garbage dump of the engine. So we have user objects, right? And we have internal objects. And you may have seen this from some of the dynamic management views, that there's something called a user object counter and an internal object counter. And you may be asking yourself, what's the difference between the two things? What makes these things up? Well, from what I found, in user objects, it's made of things like temporary tables, which you're all probably familiar with, table variables, and then these two uses of table variables that you may not be aware of, a table-valued function return value, which is really a table variable. That's the way it's treated. And a table-valued parameter, which is treated also like a table variable from a storage perspective and how we internally implement the allocation of it. Then we have temporary procedures, which I'm not going to talk a lot about, the fact that you can create them, but the scoping and so forth is very similar to temporary tables. The only storage required, of course, is to store the actual code of the actual procedure. And then user-defined objects, which is an example I just showed you. You could actually put your own objects in Tempdb if you dare do that. Obviously, after today, no one will actually do that. Now that they know that if you crash, you'll have no consistency. What about internal objects? This is the way I break down internal objects. Okay? Sorts, which are used for things like order by clauses and index rebuilds. Work tables, which may be a little bit different than you've seen or heard of before, but basically you're going to find out work tables is a special case in SQL Server for the engine to create its own temporary tables. Work files, which is going to be very equivalent and absolutely only used for hash joins. And then the version store, which is something you may have read about that involves our ability to support row versioning. So if you have to think about all the internal objects in the server, okay, when you see that internal object counter, they're made up of these. The version store, as it turns out, is actually carried separately as a counter, and it's not in the internal counter, but I counted it here in my categorization of internal objects. Okay? Now, really the big difference is the following. For user objects, it's all about explicit T-SQL. Okay? You do some T-SQL command that results in the creation of these things, right? The latter is all implicit. There is no create work file command, last I checked in the docs. Right? There's no create version store, there's no create sort, things of that nature. It's implicitly used by the engine to support the T-SQL commands that you use in your application. And then you have certain dynamic mention views that we built to track the usage of these, either for the entire server, for a given session, or even down to the task level. Now, of course, these dynamic mention views are going to be pretty volatile, right? Because these things are being created and dropped pretty frequently. But if you poll these over time, you'll get a feel for the usage of what's going on in these objects. Okay, let's dive into user objects, okay? I mentioned the examples on here. One I didn't kind of show on here, though, you'll notice is online index space. And that is that when you do an online index, we actually might create user object allocations for the online index build inside Tempdb, okay? And then the other thing I point at the top that you may not be aware of is that SQL Server itself and its various functionalities may also create temporary objects. Just go into MSDB and search through all the stored procedures and you'll find tons of uses of it, right? Where we use table variables and temporary tables. So when you're trying to debug a problem or you're trying to figure out who is using Tempdb space on my system, it could be SQL to support SQL agent, to support the new utility, the utility control point functionality. I saw all sorts of different examples, database mail, various features like that will actually create temporary tables for Tempdb. So this is my definition of user objects. The most common one that you all know about are temporary tables. Okay, Bob, yes, this is supposed to be a 500 level talk. Why are you going over temporary tables? Because there's some aspects of this that you may not know about. But let's cover some basics so we know about it, right? The scope, and by the way, if you're not aware or not, that the pound is a local temp table and the pound is a global temp table. I just, for purposes of the slide, use those little acronyms. So you know for a local temp table, the scope is the session or the proc, right? And then for a global temp table, it's all about just the server itself, right? So, the scope is a session or the proc. The lifetime is a session or proc. That first one should say actually session or proc for scope as well. But the scope of a global temporary table is last one using it, or of course the server being restarted. With caching, we do support caching. We support caching of temporary tables. It's going to be one of the most significant things you're going to learn today is about the benefits of temporary table caching, what exactly it means. For global temporary tables, we don't support it, but it doesn't make sense because you drop those or we drop them with last out. That doesn't make sense to actually do any caching for those. And then we do support deferred drop. Deferred drop operations can be helpful to reduce contention when you're actually doing drop operations, like truncation or drop table or something of that nature, and Tempdb supports that. What's interesting is you're going to find out, though, for temporary tables that are less than 8 megabytes, we're actually going to cache some pages for you to keep things a little bit faster. We'll get into much detail about that. And then I thought you might find also interesting about the name in the catalog. So if you were to actually go into sys objects in Tempdb when you've created a temporary table, you're going to see something like pound, the name you created, a massive number of underscores, and a number. Well, where does the number come from? The number is just a simple incrementing number in the engine. Every time one comes in, we just bump that number by one and give you the next number. So that number is not significant to you because you just care about the actual name itself. But if you're diving into the internals of how we store it, and you're looking at sys objects or anything in there, you're going to see these kind of crazy names. Now, when we do caching, we actually change the name. We're going to go into the details of how we actually change it. And then for global temp tables, it's just that name. So what about table variables? Table variables have a scope of the batch, right? The batch itself, not the session, the batch. It's only particular for a given batch or the procedure. And you can't do select into. Caching and deferred drop are supported just like they are for temporary tables. So we do support those just like temp tables. But there's no rollback allowed. Did you know that? Did you know we don't support rollback? And then one of the reasons why is that when you do modifications to table variables, we actually do an implicit transaction within each operation. So we don't support a user transaction against table variables. So a key for you to think about is if you ever have a scenario where the Tempdb log is not getting truncated, don't blame table variables. That's not likely your cause, at least for some sort of open transaction, right? Because table variables don't support rollback, so you can't do a user transaction on it. And there's no stats or create index. And then here's basically the differences about TVF and TVP, that they're actually really treat them like table variables when you use them. Okay, let's talk about temporary table caching. This is above anything I found doing my research in this talk today, if there's anything you can do to improve the execution within the engine of your server, is to ensure that you're using this feature, okay? And it's something that we added even back as far as 2005. You may have read about it some, but I thought there's some internal details about it you will not be aware of. Okay, first of all, this is what we cache. We actually cache memory objects. There's something called a cache store in the SOS system, and there's a specific name for one for Tempdb called cache store temp tables. We cache system table entries. This is going to be the most significant thing you're going to find that we do to help reduce contention for the use of temporary tables. We cache the system table entries. Not all of them, but most of them. And then we keep around 2 pages for tables less than 8 meg. We keep around an IM page and a single page for the table you had. In fact, what we do internally is we actually truncate your temporary table when we cache it. Okay, when we're going to support the caching, we're going to truncate it and keep around these 2 pages. And as you're going to find, it can potentially support and help you with reduced page allocation for system pages because we keep these around. Now there's restrictions. We only support caching when you use them in procedures, function, or triggers. No ad hoc queries or dynamic SQL. Okay? The reason why is we need to tie the caching to a plan. Well, if you do a create table in a batch, we don't cache the create table. So there's no way for us to tie your temporary table to a plan since the create table itself wasn't cached. But if it lives inside a procedure, we can cache your procedure in the procedure plan itself. Because all these temporary table caching, this memory object I'm talking about, is tied to your procedure plan. You can't do explicit dynamic DDL, you can't do explicit DDL statements after you create the table inside the procedure. Now the reason is because since we do this caching up front of the schema and everything about that table when you create it, if you make changes to it, we don't support recaching those changes. So we don't allow you to make any changes to it once we cache it. So we destroy the cache entry at that point, except for drop table. This is an optimization I think we made pretty recently here because from our memory, when we saw this before, we thought when you do a drop table statement inside a procedure that we would invalidate the cache because it's a DDL statement, right? Drop table. But we do support still caching your temp tables even if you explicitly drop it. And there's no named constraints allowed. So you can't actually create an actual unique name constraint because there's no temporary name constraint concept. Yes, you have a question? The question is, can you have indexes if you have this feature? And the answer is yes, you can, because you can actually put in either a unique constraint or you can put in an implicit primary, like a key, like primary key clustered or non-clustered, and we support that. In fact, we actually support caching that. So we actually tie the cache to an object plan. We reuse these when they're not in use. So this is one thing that can kind of maybe confuse you. We don't cache something that lives for a given plan for all users because it's a unique object in itself, right? So when somebody is using the cached plan and another user comes along with the same procedure, we have to create another one because each of these tables are unique to your usage when you're using them. So effectively, if you had 100 users all out there creating these tables that are going to be cached, you've kind of built a pool of cached temp tables tied to a procedure plan. Now, the problem with this I've seen is that we can destroy these when there's pressure because it's all based on this cache store we create. So we can, when memory pressure occurs or when we have what we call a clock sweep to the cache store, we can actually destroy these. Now, here's the part that you just mentioned about indexes. We can actually cache if you've got a clustered index key, but we don't cache the non-leaf pages, okay? So you can say it's a clustered index on the create table, and we'll cache it. It's supported, but the non-leaf pages have to be recreated when we actually go back and use that table again. And even for a non-clustered index, let's say you use a unique constraint, for example, or a primary key that's non-clustered, we'll actually even cache the non-clustered entries as well, not, though, the entire non-clustered index. One point about unique constraints on there, and we'll talk about it near the end of the talk. If you do use unique constraints, there's an additional system table that must record that information. So you might introduce new contention that you didn't realize you had before by using that type of feature. You have a question? Excuse me? I can say unique constraint, like a unique constraint, for example, on a column, and so that's fully supported. So, but you just can't create a specific name constraint later on because that's unique. That's for the entire Tempdb. It's not specific just to your table. All right. let's look at temporary table caching because it's an important concept. Okay. 20 minutes till a break, just in case anybody's wondering. You mean like table value parameters? What? It's tied to a plan, so it's tied to your procedure plan. So it's independent of your parameters. It has nothing to do with your parameters. It's just tied to the actual procedure plan itself. Okay, so let's do this. I've got this. I've just got a batch that just create table and drops a table. And I've got another one that is going to create a temporary, just a stored procedure to go create a temp table object. That's it. That's all I'm going to do. And I've got another query here. This is actually a set of perfmon counters. Whoops, I didn't mean to open it from there. That's interesting. Let me back up here. Okay, so I have a couple of perfmon counters that you might find interesting. One is temp table creation rate, and then page latch weights. I'm just going to see as I run these what kind of contention I might get, or what kind of a latch weight contention I might get. And temp table creation rate is really important because if I'm actually properly using cache temp tables, this value should be 0. Because this only is recorded as each temporary table is created. So when I first create it, I expect it to go up, but after that, I don't expect it to be 0 for the entire rest of the execution. So you see the two objects I have. So let me just create these guys. Here's my proc, and I record the object ID, because I'll need that later, and I create the temp table. So what I have in here is I have a couple of batch files that are going to run these in a loop. Let's see here. Temp caching. So one comment I didn't make at the start of the talk. I am one of those really bad speakers that doesn't upload their slides before the session. You may have noticed all that when you're in the room here. That's because I'm working on these things to the last second. I mean, I'm really polishing them before I show up. And also all my scripts. I will definitely upload all these tonight, the slides and all the scripts. At any point in time, if you feel like I can't get them from the website or have issues, just email me directly. I'll send them to you. It's very small. It's not that big to send you these things. So all these scripts and queries I'm running, I hope you've not been furiously writing them down because I'm going to give you everything you need to show you what I'm doing upstage up here. So, okay. So I've got a couple of batch files. One's going to use this ostress utility that we have that's published with RML utilities to run the batch 100 times, 100 users, 100 loops. One is to run the proc. Same thing. So let's run the batch first and see what happens. So I run him, and temp table creation rate is pretty high. It's like at about 400 or 500. Page latch weights are also pretty high. You can see each of these, it's pretty significant. Page latch weights is up to 56,000. That's a lot, right? So this is kind of natural problems that you always call us with, right? I've got all sorts of page latch, contention weights, and all based on temporary table creation. So I go back and look over here, and it took about 21 seconds to run that. Now let me go run the procedure version of this. And I'm just doing the same thing, right? I'm just doing it in a proc. And what do I get? Let me go over here now. My temp table creation rate spiked up to 100 real quickly, but now it's 0. I still have some page latch weights, significantly less than I had before. I still have to have latch contention potentially on actually creating and using these things, and we'll explain a little bit why. But notice the difference of the graphs, the duration and the number of weights here. And if you go back and look at the time, it took 6 seconds. So creating temporary tables that are not cached took 21 seconds. Creating the same number of tables that are cached took 6 seconds. Just shows you the power of actually what we're doing. Yeah. Why are we caching just 2 pages? I don't know the answer of why we chose not to cache more than that, but I'll show you later how with a certain trace flag you can cache an entire extent, a single extent as well. Okay. I got more details to show you a little bit of the logging differences between these two operations at the detailed log level, and it kind of explains a little bit of why there's actually less contention. We'll look at that later. One of the things I've seen people mention before is about temp table caching has limits, like it's 10 or 5 or 30. That's not true. I can cache up to 1,000 on my laptop if I wanted to. It's all about memory. It's about the SOS cache store itself and the memory it takes up. What's the question? It can be memory pressure, but it's also triggered by the number of allocations you do. Reserved memory? Given the time we have to make to the break, I'd like to defer that, if we could, until when we come back. Come to me up here front, and I'll answer that question when we first start out. So let's get into internal objects. That's a fairly complicated question. I know exactly how to answer your question, but it'll take a while. Okay, so we talked about temporary objects, talked about table variables. Let's talk about internal objects. Sorts, work tables, work files, version stores. The reason I say work tables as a category is that there's a lot of different uses of this work table concept. And in fact, I did a pretty exhaustive search in the code to find out all the different uses of Tempdb in this talk. And the one I found that was the most frustrating was work tables. Because, as you'll find, it's an internal playland for the developer team, creating their own temporary objects inside Tempdb. Sorts, work files, and version stores have specific purposes, but work tables is just kind of open up to anybody who wants to use it. Okay, let's talk about sorts. So first of all, sort is not technically a work table, even though you might have heard that term, that it is a work table. And the reason I say that is because there's a counter, a perfmon counter called work tables created per second and work tables cache used. Sorts don't use that. It doesn't hit that. And in fact, inside the source code, when we create work tables, there's a specific routine we use. Okay? And sorts don't have anything to do with that routine. Sorts use Tempdb as a paging mechanism for query memory. So when you hear about sorts, you think of workspace memory or query memory, and this is a backing for that. When we exceed some threshold, which we're not going to get into in this talk, it would take an entire session to go into those details. And in fact, I don't know if Adam Mechanic's in the room, but I think he's doing a session all on workspace memory. So if there's any details you want to know about workspace memory, go to Adam's session. Oh, he's right here, so you can come and bother Adam about it. Yeah, you're welcome. I'm not getting the details of the calculations of that, but you just need to know that whenever we decide to spill a sort onto disk, we're going to use Tempdb, but we're not going to call it a work table. And it's something called sort warnings, which is a profiler event, which is your indication that we have to use Tempdb for the sort. I made a note on here that it's a profiler event, and in Denali it is an X event as well. So you can actually track it from that perspective. And one nice thing about it is, at least inside 2008 R2, it's a default in the default trace. So you can look at the default trace to see if you've had any sort warnings come up. The space you use for these, including memory plus disk, may be a little larger than you expect. In the testing I've done in some cases, you'd expect it to be the size of the input of the sort, and sometimes it exceeds that. And there's really no visible perfmon counters to show you the spills, which I found interesting. I didn't really know that. I just kind of assumed there's something out there that would give me something that was very indicative that I was doing a spill, and that doesn't really exist. Now, how do we do allocation of these? They're all uniform extents when we allocate for a sort. There's no mixed extent needed. It's all internal. And we have our own internal caching extent mechanism to tell us what extents had we already used for the sort so we can reuse those. And the extent allocation and deallocation are logged. That's it. There's no system tables. There's no anything else. It's just about logging the allocation work that we're actually doing. And if you ever try to look at one of these pages, like in a header of the page, you'd see a type 7. If you see a type 7, you'll know I'm using a sort. So let's go look at sorts. Let's look at the internals of sorting. I told you were crazy if you're staying for this. Okay. So let's see here. So here's my sort query. Rangers to the World Series again, my database. And I've got this table called Josh Hamilton at bats, which are all home runs. If you look at the table, every one of them is a home run, right? Because I'm just a big Homer fan. Although he's not doing too well so far in the ALCS, I don't think so. I also have a query here to show you how to go get a sort warning from the default trace. So if I run this query right now, I'll see if I have any out there. And I don't have any out there. And then, this is when we get into more 500 level stuff, right? I'm going to start cracking the log now for you. I'm going to show you the actual logged operations of what actually happens in a sort. So if I go and crank out this query, this is a heap table with no indexes, and it's pretty large. So if I immediately go over for sort warnings, I'm going to start expecting to see something. And I do. So immediately I start seeing multiple sort warnings, which I'm having to spill multiple times onto disk to support this sort operation. So when you run this query and you see this, there's some optimization for you here. It's probably too big of a sort. There's a lot of sorts running. You have memory pressure, one of those kind of type things. And it's actually displaying the results at the same time as it's finishing up the sort. And I'll start looking at these log records for you. Now here's one technique I use for Tempdb. Whenever I want to kind of look at the log in a very small sequence, I first checkpoint it. Why do I checkpoint it? Because I want to truncate it down to a really small level first. So I'm going to, actually, I didn't want to do that. Let me see if there's still something in here. There probably is still some pieces of it in here. Yeah, that's what I wanted you to see. So look here. You see this name, transaction name sort init? That's the indication of a transaction internally to go log the allocation for a sort. And also wanted to show you that you can see here, if you use this when you're looking at FNDB log, if you look at the description column, sometimes we print some interesting information here about what's going on with the logged operation. So this is kind of just a sequence of events here of doing log. Now, how do I know I'm logging allocation beside the description? Because the context of the things I'm doing have these names called GAM, PFS, IAM, and so forth. That's all about allocation. Anytime I'm recording logged operations on those kind of contexts, it's because I'm making changes to allocation pages, which is about doing allocation. So if I were to go look at one of these pages, like I'm allocating this page here, 31138, I think that's in hex, if I remember correctly. 31138, and that's my decimal equivalent. So this is one of the pages I need. And if I try to go dump out that page, what do I get? I get a type equals 7 right here. That's my sort page. Okay? So this is internally us in the server taking the sort memory of sorting our operations, writing out pages to disk to support our spilling operation, and they're actually just pages. Now, it's a special type of page, but you can see some of my data in here. One of my columns is called home run. There's a lot of spaces, too, as well, trailing spaces. So this is just an example of one of those pages. So here you can see how we're using Tempdb to support a sort. We spill over it. Again, it's just a backing or a paging mechanism for our temporary operations. Yeah. The question is that how long are those extents allocated? We do keep a cache of what extents we used, but for each sort operation, we deallocate them. We don't cache and keep the extents used after we finish a sort. It's just we cache it for the purposes of our internal sort run. So when you do a single order by, we can reuse some of those extents. But when the sort's done and completed, we deallocate everything. Do you mean see the pages themselves? Actually, the pages could still be out there, right? Because we don't zero them out. But how do you know which ones to look at? You have to look at the log, right? Okay. Okay, we have about 5 minutes before we're going to break. Remember we said a 10-minute break. I'm really serious about a 10-minute break. Because if we don't do a 10-minute break, we will not finish this stuff. There's no way. Just a quick pulse for you. Is this kind of the internal stuff you're looking for, or is this like way too basic? Okay, good, thank you. I got to know, because I can like bring up the debugger just for the grins of it or something if we need to. So, all right. So some things about indexes and sorts, because I've seen some actual incorrect documentation on this. Index sorting for your indexes is normally built in the user database, not in Tempdb. Okay. And I've tested it. I mean, I've tested the heck out of it because I saw somebody document that actually sorts for indexes are in Tempdb by default. That is not true. I ran indexes till I blew in the face, and how did I know? I looked at the log, right? I looked at those kind of log operations. However, if you use the sort in Tempdb option, we do. So if you use the sort in Tempdb option, we take the sort, if it has to be spilled, okay, and we actually place it all in Tempdb, just like if you did an order by type clause. Now, sorts for indexing use workspace memory just like an order by type clause, right? So it could be serviced in memory. But if it's big enough or there's memory pressure, we actually have to flush it and spill it out into either your user database or into Tempdb. And then one thing I found you might find very interesting, we have this option called index create memory option. And if we have enough memory, we'll definitely exceed that option. So that's a maximum option. Like this is the max memory I want for my index create. Well, it's not really a maximum. Because if we think we have enough memory around, and this is assuming we're playing with the entire workspace memory rules, which is kind of complicated enough as it is, we potentially use more than what that option says. Okay, let's talk briefly a little bit about work tables, and then we're going to come back after the break, and we're going to start diving further into it, and we're really going to get into allocation, the internals of how allocation works in the server. So work tables are temporary row sets, and as I told you, they're really temporary tables for developers. So think of a developer has a piece of code in the engine or some sort of a new feature like service broker where he says, you know what, I need disk storage to do something for the code I'm writing. I need to store something somewhere. Well, he's not going to create a user database for it. He's not going to create his own file for it. What he's going to do is he's going to build internally a temporary table. Okay? But he's not going to go through the create table pound X mechanism. That's kind of silly because he's inside running in the engine. So that's what work tables are all about. We actually call the same internal routines that a create table statement would call. But you build the schema inside memory structures in the engine. You don't have to store it in system tables. So no system tables required. They're just data pages in Tempdb. Actually, if you looked at them and can see them, they're just data. But they have a specific property, and that is they have negative object IDs. So if you were to grab a work table page header in Tempdb, or if you happen to be just looking at a page for some reason and you saw a negative number, you will know those are work tables created for this specific purpose. And there's no system table at all. So the logging is all about allocation, just like it is for sorts. The difference is that we can use mixed extents. It's not uniform extent allocation. We can actually use mixed extent allocation to support these. In fact, that's actually the default. If these work tables exceed the normal mixed extent algorithm for greater than 8 pages, we'll start using uniform extents. And we do have a caching mechanism. You asked about sorts keeping extents around. Work tables do keep extents around. So you have cases where work tables get used. You might find the internal page counter in the DMV to be greater than 0. And those account for the extents that we've kept around for work tables. But if we're low on space, we'll actually start deallocating those because we need to take back that space. All right, and then 2 other things to point out before we get into a little bit of demo here. The 2 big counters for you are work tables created per second and work tables from cache ratio. Work tables created per second are actually going to give you an indication of how many things we're creating. If you see that counter greater than 0, you'll probably be hitting one of these scenarios I'm going to talk about after the break of how we use work tables. We need to be back here at 3 o'clock. I'm literally going to start talking right at 3. So take your break for a second. Please, I don't want to take any questions in the break to make sure the rest of the demos are going to work. So we made it close to where I wanted to make it for the break. There's probably a couple slides where we can kind of get through it quick enough. I want to make sure there's plenty of time for questions at the end. I want to try to make sure I finally do that. So let's make an agreement, though. Try to hold your questions until the end. Write them down, make a note or something, and hold them to the end. Also, at the end of the talk, I'm going to stay out there as long as you want, or you can come to the clinic tomorrow or send me an email. So I ended our before the break discussion on work tables. Remember I told you it's developers playland. I apologize for the devs in the audience who I say that from, but that's what it is. Look at this crazy list. These are all the types of features inside SQL Server that I could find, and there probably are others if I spend enough time looking, that create these internal temporary tables. So, service broker. And the interesting thing about service broker is if you actually try to go monitor the log or the usage of Tempdb as you're starting up SQL Server, you'll see all these temp objects getting created. You're like, where's that coming from? It's coming from service broker. Service broker uses it for all sorts of different reasons. There is some X event tracing, though, built in to show you some of the service broker features that are using temporary tables and using work tables. XML documents like OpenXML, CheckDB, fact tables that CheckDB needs are using work tables behind the scenes. Make a quick note that I've seen recently posted that the estimate-only option for CheckDB, which tries to estimate how much of this work table space am I going to need, it may have some problems. So just be aware of that when you use that option. Spool operators, table spools, eager spools. Whenever you see a spool operator in a query plan, that is a choice the engine has made to take what's called an intermediate result set. You may have seen that term used before, and spill it to disk. And it's used all in the process of optimizing your query so it doesn't have to reread things from a previous operator. So spool operators use work tables. Something called an exchange spill. What the heck is an exchange spill? Only seen with parallel queries. There are cases where exchange operators as part of a parallel query must take their results, and for normally putting things in memory, it has to spill to disk. There is actually a SQL trace event to record this exchange spill, and also in Denali and X event. Excuse me. Even merge joins have some small amount of temporary work table space they must need in some cases. Merge joins don't use workspace memory. This is a specific explicit work table created in the engine. Cursors, this is one I've definitely seen people see before, and specifically static cursors require quite a bit of work table space. Key set cursors can as well for keys. There are perfmon counters, though, to track specific cursor work table usage if you're running into that. And then finally, lob variables like varchar max. This is an interesting one when I started experimenting with this. This is a pretty complicated system for lob variables. And what I mean by lob variables, I mean like a variable inside a procedure. That's a varchar max or something like that. Certain amounts of sizes of these won't require temporary work table space, but exceeding certain sizes will all of a sudden, you'll start seeing your work table count start increasing. So what do one of these things look like? How about just a really simple example? Let's keep our log, our FNDB log query open for this. And let's go pull out a very simple example. And that is CheckDB. So you're asking yourself, what is that little trace flag for? Warning, warning, undocumented trace flag up on the screen, right? Don't rely on this behavior. Don't tell anybody. No, I'm just kidding. You can tell anybody you want. So remember I told you before that work tables are cached. So we keep a cache around of this allocation. So you might come along and try a little experiment like this and go, wait a minute, I thought Bob said I'd see some sort of logging of extent allocation. Well, if you don't see any, it's because we've got this stuff cached already, you won't see it. This little handy-dandy trace flag says, skip that caching stuff, go log it and actually create the work table on disk. So for purposes of this demonstration, I'll use the trace flag. Or I could restart the server, but work tables actually may get created by broker or somebody else. They may get cached, and I may be using the cache. So I'm just going to run CheckDB, use the trace flag, and then go look at the log. I didn't truncate my log, which I should have first. So let me go back and do that again. Well, it might be at the end of the log down here. Let's see. Yeah, I think it's there. Let me see. No, it's not there. Let me go back. Let me do this. I'm going to truncate it. Remember I told you that be careful on checkpoint for Tempdb? The hard checkpoint? This is all these pages we're trying to flush out a disk that I've been using. Probably been faster just to restart the server. With my restart service, which somebody pointed out you need to be an administrator to run that from PowerShell. So just in case you're wondering. Let's do that. I think Tempdb is not that large, so. Service, force, and the SQL Server. Okay. Waiting for stopping. Okay, it's already started. So let me now do this. Oops. I don't know why that's what. Oh, there we go. Sorry. So let me checkpoint this. Run it. I got 2 records now. I'm good. Now let me run this operation again. And I should already see the log records. So here we go. So this is all that was required to build that work table. This right here. And what do I have? I need to allocate a mixed extent. So in order to support this work table, I allocated a mixed extent and using this page. So you're probably asking yourself, well, that must be the page, A8, right? That's got to be the work table page I'm after. But remember, it's a mixed extent. So let's see what that page is. That page is 168 in Tempdb. Okay, am I the only person that hates that? Good grief. What'd I say, 168? Okay. This is the downside of presentations for large, because your fonts have to be big and your windows have to be big, but okay, that's all right. Not complaining. All right, let's dump this out. And if I look down here, there we go. And there is our negative object ID. Remember I told you a negative object ID? So negative object ID, and you're thinking, okay, what kind of page type is this? It's a 10. What's a 10? That's kind of weird. So let's try with print option 3. An IM page is page 10. Let me format it for you. And there we are. Now notice here, though, there is an extent that's allocated as part of the IM, page extent 208. So let's go dump that page out. And it also has, a page type of 1, a data page. And it also has a negative ID. And if you actually go look at it, there's nothing there because we don't need the data that's on there, right? But this is an actual work table allocation. So if you were to look at any pages, see negative object IDs, you can see the minimal amount of logging that's required for this. It's almost nothing to do the logging for these things. So minimal amount of logging needed for allocation. Pages are stored in Tempdb. All about internal usage for developers. Okay. What about work files? There's definitely some misinformation and misconception about work files. Work files are used for only one purpose in the engine, and that is for temporary storage for hashing, specifically for hash joins. A work file in itself does not equal the use of Tempdb. If you're looking at the work files created per second counter, and you see it above 0, and you think immediately, I must be using Tempdb, that is a false statement. I can prove it. I can run a hash join, and I can do breakpoints in the code to prove there's no allocation occurring because of it, right? However, in some particular cases, because of the size of the hash we must do, or because of memory pressure, we can't fit the entire hashing in memory. So we go through this process of recursion bailouts you may have heard of and so forth, when you actually can't even do the recursion part. We recurse and we split the hashing into smaller units. When we have to start doing this recursion and partitioning, then the work files have to use temporary storage space, okay? And also hash operators themselves can use work tables, the previous thing I just mentioned. So even though that wasn't on the list, a hashing could internally use a small amount of work table space. It's absolutely different than work files, though. So if you get a hash warning in SQL Trace or through Xevent and Denali, that is an indication, just like a sort warning, that we had to recurse the actual hash join and spill it onto Tempdb. But it's a little bit different than work tables in this sense. We don't normally use the buffer pool hashing mechanism for these pages. This is a paging mechanism for hashing only, kind of like sorts, but it's got some special properties, right? We actually store them as pages. Checksum still works in these pages, but they're not hashed. So if you're looking at like DMOS buffer descriptors to look at all the pages that are hashed from the buffer pool, you would never see any work file pages in that area. We only allocate uniform extents. We don't log anything. So you can be trucking along, running these hashes, trying to look at the log yourself like I'm doing, going, I don't ever see anything. You're thinking you're doing it wrong. You're not. We don't log anything. We don't need to log anything. And the page type is 6, specific page type for work files. Now, a couple of points, and the point at the bottom is most important here. If you're planning on tracking extents allocated per second on your server and trying to make sure, oh, I'm going to track all the extents allocated per second and see what's going on, it doesn't record for this. That's because it's in the code for doing non-log extent allocation, we don't bump this counter. But we do bump pages allocated per second. So when I was doing my testing to see if I was hitting this problem, I would look at two things. have I hit a hash warning, and do I have pages allocated per second going on in the engine? If that was going on, I knew I was seeing Tempdb. But of course, you can see the DMVs that record DM file space usage. You can see them increasing. The problem is, we record everything on the internal counter. So work files and work tables are both counted together in that counter. Version store is separate. But all work tables, all sorts, all work files, all go into that internal space usage counter. So you don't know which one it is. And the only ways to figure it out is to look at this hash warning event and then look at pages allocated per second during that sequence. So when you think of work files, you think of hash joins. When you see work files created per second get persistent and get really high, it's usually an indication that we're doing this recursion and we're hitting this problem. So if you're just looking at perfmon and you see a small number of work files per second going on your engine, it may not be a bad thing. Maybe hash joins are okay for you. But if you see it really high and for a persistent period of time, that's time to look at optimizations in combination with this hash warning event. What about the version store? We use this for a lot of different reasons, specifically for storing row versioning information. And typically used by snapshot isolation transactions, or if you're using read committed snapshot isolation. But we also use it for online index rebuilds, triggers, and for supporting multiple active result sets. So triggers, for example, now are all implemented using row versioning. So there's special code to note these extents are a version store. That's why when you look at the DMV and you see an internal counter, a user counter, and a version store counter, our code is set up specifically to designate any extents allocated for the version store go into that specific category. And that was the one thing we try to do, is to break off to tell you how much of the version store are you using in Tempdb, because it could get quite large. And you have a lot of control over that based on the use of your application. You do have control implicitly, obviously, over work files and work tables based on what feature you use, but it's a little harder to predict its size. With version store, it's a little bit easier. Now, nothing's logged for version store. The buffers are hashed, and the page types are actually index pages, even though it's really not an index. It's kind of an index. Internally, we actually use an append algorithm to make these very, very efficient for quick lookups of your version store row information, because you need to do it very fast. And so we kind of use an index feature, and so that's why it's actually tagged as an index page, but its structure does not look like a normal index that you would see. And there's specific DMVs and perfmon counters to monitor more detailed usage of these. The interesting part of the deallocation part is that we do kind of keep these around a little bit. And in fact, we kind of defer their destruction in a kind of a garbage cleanup fashion. So you can go run some sort of repro where you go set read committed snapshot isolation on a database. You can then go maybe make some modification in that database to a table and then go query from that same table. And all of a sudden your version store counter is going to go up pretty high, depending on how much you're modifying. And then you're sitting there looking at the DMV and you see it's maybe at like 2,000 or 3,000 is sort of the number of pages that are being used. And then about 2 seconds later, you look at it, it's down to 0 again. It's because we perform this cleanup all in the background asynchronously to deallocate what you've used. While you're using the version store records during that transaction, we have to keep that space around. But they're not logged and they're hashed, but it's okay. You can use these different perfmon counters and DMVs to track how much actual usage is occurring. But be careful. You may think to yourself, well, you know, I'm not using snapshot isolation transactions. Why would I even see this? Well, if you're doing online index rebuilds and you've got other modifications coming in on that same table, we have to use versioning to support that feature, or triggers, for example. Okay, now, you've heard a little bit now about the different types of objects that are in Tempdb. Let's talk about Tempdb allocation. First of all, when it comes down to it, it's all about contention on these 3 pages. The only reason I'm doing this talk on Tempdb allocation and the principles behind allocation is because people run into problems with contention on these 3 types of pages: PFS, GAMS, and SGAM pages. Okay? Now, there's some unique things about Tempdb allocation that I found from doing research for this talk. One is, it is the only place where we do non-logged allocation operations. No user database feature that we have would do a non-logged allocation operation. And it makes sense based on the whole thing we talked about, recovery and things of that nature. But it's the only place we do that. Second of all, the algorithm to do mixed extent allocation is actually a little different for Tempdb. For the most part, the allocation algorithms in the engine are the same for Tempdb and user databases. Okay? For the most part, except for some of these principles. And mixed extent allocation is one of those, where we did special code to try to handle that because, for the most part, because you're typically creating and destroying lots of small tables, you might be using mixed extents a lot. Whereas in a user database, that's probably not the case. So we made some optimizations there. In fact, I'll talk about that a little bit later. There's a special cache of extents, a special cache of what extents are getting used, as I've talked about some of these different features, work tables and version store and so forth, where they record, these are extents I use, I want to use these same extents again. And truncate's a little slightly different. So in the case of internal truncation, which I'll talk about in terms of how we do caching for temp tables, normally when you do that, we just actually deallocate the IM and the first page and everything for these small tables. But in the case of caching, we're actually going to keep some of them around to make your temporary table access more efficient. Now, what's the problem with Tempdb allocation? Why does it even matter to you? Well, first of all, you do a lot of frequent create-drop of objects, right? You don't control internal object usage explicitly. In fact, who can control this stuff? Internal objects are used in so many different places, and the allocation and deallocation happens very frequently here. So this is one of the more bigger pain points you have. This is why Tempdb allocation is more of an issue than other databases. Only one file group allowed. You only get one, the primary one. And so you have no placement of objects. You have no idea where they can go. You basically just get a file or multiple files in a single file group, and you kind of like cross your fingers and hope you're doing it right, and it works. And then the default ship of the product is one very small Tempdb database and log for all of this, right? So these are the problems you face when you're considering allocation in Tempdb. Now, I want to introduce something that you've not seen before, an undocumented trace flag, 1106. Everything I've shown you so far is about using the log to look at how we're doing temporary table allocation, right? I've shown you some of the different operations for logging. Trace flag 1106 creates a new ring buffer in DMOS ring buffers called ring buffer alloc trace, specific to Tempdb. So we can actually do, in the next couple of slides, certain types of modifications, use this trace flag and go look at a tracing of how the allocations worked in Tempdb. So some things about allocation principles. Tables first require mixed extents. You may know this. Update pages, you need a mixed extent. Then after that, you need uniform extents or full extents. Every table first needs an IM page. Anytime you have a table, you've got to have an IM page. Okay? IM pages are always part of mixed extents. No matter what trace flags or anything you turn on, anytime you have to create an IM page, you have to put it in a mixed extent. And of course, dropping tables require a lot of allocation page changes, right? And then most apps don't frequently create and drop tables in their own database. So these are the kind of principles you need to think about as we're going through and discussing about the allocation algorithms. Let's consider a simple temporary table scenario. Very simple one, right? And this is even in Tempdb. So first, I got to build system catalog entries. So when I create a table, I've got to add things into system catalog tables, right? System tables. So this is going to require system table page access. And anytime you need to touch pages and modify them or read from them, you have to acquire a what? A what? A lock, but what else? A latch. Hooray, whoever attended my latching talk last year. You need a latch, okay? So you need locking, but you also have to latch these pages as you're modifying them and reading from them. So guess what's going to happen when a lot of people want to do a bunch of these? You're going to get some contention on system table pages from a latch perspective. You also may get some locking, but what I've seen mostly is latch contention. The next thing you have to do is you have to get an IM. You have to allocate an IM page. I said every table needs an IM page, right? Well, what is that going to require? You got to go find a mixed extent where you can get a new IM page, and you've got to make and mark this in the PFS page. So you've got to search something called an SCAM page for a free mixed extent, and then you got to go into the PFS once you find it, and you got to make a modification there. So if a lot of people are doing this, you might have some contention on latches on those kind of pages, right? Then you need to allocate let's assume we're also creating a row in here. We're inserting one row, for example. If you just create the table, you don't need to allocate a new page. But you got to allocate a page, right? And then you need to record allocation in the system tables for what you just did. Now, when we talk about allocating a page, because it's a mixed extent, I got to go search that SCAM thing again because it's a new page. And I got to go find a free one, and I got to go update the PFS page. I got to search in the PFS for the free one. I got to update it. And then I've got to go update the IM. Now, when I drop the table, I got to just undo what I just did. I got to reverse the things that I just did to create and put this page in there, right? Now, if you look at this very carefully and you look at the red triangles, you can see some things that might cause contention if a lot of people try to do this at the same time. You've got system table pages. You need to allocate an IM, so you've got a PFS page. You've got other system table pages for allocation. You've got SCAM and PFS. All these types of things, if everybody throws as hard as they can into the server these operations, you're going to have contention, and it's all going to be about latches, okay? Now, temp table caching changes the game radically because everything I just drew up in those circles up there, I don't do that anymore. because I cached my system table entries, I cached my IM page, and I told you I kept around one page. So I don't need that anymore. I've got it all cached now in system tables. So it's really efficient. Now, I kind of lied about the first one. When we do caching in temporary tables, there is a small amount of a change we have to make in a system table page. So there is still possibly a small bit of contention that might occur, and we'll talk about that. Let's look at it. And I think in this one, we're going to use the trace flag. We're still going to use the log. Sorry, I lied. Okay. Okay. So all we're going to do is, I wanted you to look at the log records for a table that's created, and then when we cache it. So I'm going to effectively use the same thing that I used before. Okay, so if you go and look at the batch case, where I created my table, inserted table, and I just dropped it, if I look at the log records, oh, here we go. Let's checkpoint this again. Let's do this. Okay. Now let's go look at our log records. Now I've only put in certain columns on log. I want you to look at all the things. Just by looking at the alloc unit name, I want you to see the stuff we have to do. We have to touch these system tables for inserting the object, for inserting the columns, for inserting the row set, for the allocation units. Look at all that stuff. Now look here, when we get to this system table, it gets worse. In this particular case, we had to split a page. So we're in the process of inserting into system tables just to build this temporary table. And as part of inserting to a system table, I didn't have enough space, so I had to actually create a new page for a system table. So this problem get a little bit worse even, right, in terms of contention. Because I had new allocation I had to kick in just to support inserting to a system table. That's why the descriptions can be very nice. And I come along here, I had to come along in this particular case, and I had to actually create my IM page. Well, how did I do that? I had to go in and modify something in the PFS, where I did my first allocation. I allocated the fact that I'd done the IM page. Now, you don't see anything with an SGAM in here. You don't see any context of an SGAM. This is because there was a free mixed extent for me. I found a free mixed extent as part of this, and I just went ahead and allocated an IM page and recorded in the PFS that I did that. But I don't have to touch the SGAM. I don't have to make any changes there because it's a free mixed extent. And if you come down here later, there's a lot of different operations I have to do. And in fact, all of this, if you look at the transaction name, is all about deallocation because I dropped the table, right? Remember, I haven't cached anything here. I'm literally creating it all, allocating it all, and dropping it all. What happens when I do this for a cached table, though? So let me checkpoint this again. Let me bring up that procedure that I had. Here it is right here. I'm going to go ahead and I'm just going to create it again just so I have it. Now I'm going to keep that object ID around. I'm going to need that in a second. That's the object ID of the procedure. Okay? And I'm going to go ahead and I'm going to look at this logged operation. Sorry, let me run the proc. That would help. So I run it. I'm going to look at my log records. Now, you're going to look at this and go like, I thought you said that with a cache temp table, we didn't have to do all this. Well, we have to do it the first time. We have to create it the first time before we cache it. Now, I want you to pay close attention at the bottom down here for this transaction name, F check and cleanup cached temp table. That is a transaction that we run at the very end of this operation to actually support the caching of what's going on. And I told you that it was a small lie I made with caching that we had to touch a system table, and that's it right there. Here's that system table. Okay? We are going to have to make a change there, and here's why we have to make that change. When you use a temporary table, your name looks like this. $x_. Remember I told you all that? When we cache it, we actually change the name to that. Okay? What is that? That is a the object ID of what we cached in hex. So if I took this 04258276 and converted it to an actual decimal number, that would represent the object ID inside sysobjects for my temporary cached table. So we have to change the name. We're going to talk a little bit later the details of that, how that works. Let me try to clear this, though, and run it again. It was about 60 log records to do that, by the way. 60 log records or so. Let me run the procedure again. Let me go back and run it again. It's about 25 records now. You see it down here? 25 now log rows come back from this DMV. And so what's different about it? What's different is, if you look down here, is that the only thing I'm really doing is I'm making a change to that system table up front and then inserting into this little heap that I created and then running the cache cleanup code again. So I've eliminated all that other stuff. All the other system table stuff I've eliminated. I've eliminated getting my IM page allocated and all those other type of things. And if I had not a free mixed extent for my IM page, I'd have to create a new one. Or for my initial page, I'd have to create another one as well. So I've eliminated all those things, right? Kind of nice. You can see how the logging changed things and how the caching this actually makes a radical difference. I've reduced dramatically for each operation now for this temp table what I have to log and what I have to do internally to actually create it, therefore reducing contention. Yeah, if you don't mind, can I take those at the end? Can you remember that to the end? Or write a note down? Okay. So, allocating new space simplified. My little laughing characters, because I showed somebody this, they said, yeah, right, simplified. Thanks, Bob. Not really simplified for me. But I want to give you a feeling about when we have to go for new space. You've created a table now and you've got a page. What if I need new space for more pages, right? Well, first of all, if it's up to 8 pages, up to the sequence of needing 8 pages, it's all part of mixed extents. So I need an SGAM and a PFS page as part of my allocation. I need to update the PFS and I got to modify the IM page. If I can't find a free mixed extent, I got to go search SGAMs in the rest of the file to find a free mixed extent. And if I can't find one of those, I got to allocate a new one from that file, which requires further system table allocation further page allocation access for GAM and SGAM. Can you see the sequence of how this can get really bad after a while of all these things I have to do? If it's past 8 pages, I've already filled up my first 8 pages, now I need to go build uniform extents for space. I need to search the, first of all, I'll search the PFS page based on extents that I own in my IM. I'll first try to find just free pages in extents for my object that I own. I'll search and update the GAM now, if I can't find that, to allocate a new uniform extent. Then I still have to modify the PFS and modify the IM. If I can't find a free uniform extent, then I go search all the rest of the GAMs in the file. If my first GAM interval doesn't have a free extent for me, I go search the rest of them in the file that I have. Now again, and also, when I actually need to go modify my IM, remember IMs are based on an interval in your file. So if the new uniform extent for your table exists in an interval that IM doesn't support, you need another IM page, which creates an IM chain. Can you see the madness of what we've created here? Depending on what free space is available, I have another possibility of contention on all these types of pages again. So just by allocating either single pages up to 8 or past 8 pages, I have to go touch all these different allocation page structures, and when I make a modification to it, I have to acquire a latch. When I read for one or search for one, I have to share it or potentially use an update latch. When I actually make the change, I have to use an exclusive latch. If a bunch of people want to do this allocation, I'm going to collide with them, right? I'm going to have something called contention. Okay, what about multiple files? So this is something I want to make sure it's very clear you understand how this works. Because I've heard documentation talk all sorts of different ways. It's round robin. No, it's proportional fill. No, it's something else. Well, actually the answer is it's both round robin and proportional fill. What do I mean by that? What I mean is every time we make some sort of allocation, from an extent point of view, we need to allocate a new mixed extent. We need to search for a free mixed extent for a page, allocate a new mixed extent, or allocate a new uniform extent, or find a free uniform extent in a GAM. We switch to the next file if multiple files exist. So assume you had 4 files. Okay? Let's say you first created this. They're all in Tempdb, and Tempdb first came up when you first started the engine, and you had 4 files, and they're all of equal size. The reason it's important that they be of equal size is because we need to make sure they're equally free in space. So our algorithm says, I'll go to the next file in the list that is equally free as the one I was just at. Okay? But if one of those 4 files has a lot of usage in it, and I'll use that word roughly, then we skip it and go to the next one. So what we do is we round robin through each file you've created in your file group of equally free space. So we'll just go to the next one, and the next one, and the next one, and the next one, as we do allocation. So that's why it's called round robin, because we're just going through these files one at a time. But the reason it's called proportional fill is because we're only going to round robin into the files that are equally free. Now, you may ask yourself, well, that's good. How do you decide what's equally free? Well, what we do is we calculate the amount of freeness, I guess I can use that word, in a file every so often. What is every so often? Well, every so often is the following operations. After we run recovery, when we first start up, we'll do this. When you add or remove a file, we'll recalculate this for each file. Or we'll do this on a periodic basis. The periodic basis is that number right there, 8,192 extents. So anytime we're doing these allocations, okay, and actually I need to be very clear about this term, extents. It could be a search for an extent, and not just the fact that we're actually getting a new extent. So every 8,000 or so allocations, we look at the files and we recalculate how free they are. This means in between then, if a file got a little bit big, we might skip it, right? Or we might use it when we shouldn't use it. So if we tried to calculate it on every allocation, then it would be too expensive. We'd be constantly having to recalculate the proportional fill for our files on a very frequent basis. So this is effectively the algorithm. This is how we choose which file to use when we're doing allocation. We'll switch to the next file if it's fairly free, or we'll skip a file if it's fairly used at that point in time. And you can imagine the whole idea is if one of the files is kind of out of proportion, by skipping it, we'll eventually bring everybody into proportion with it at a certain period of time. There is a trace flag, undocumented again, 1165 that I found, that if you turn it on, and say you turn it on with trace flag 3605, you can dump out to the error log this calculation. And you can see how many extents exist for each file, and you can see something called a skip counter. And the skip counter is how many times we predict we'll have to skip over that file until we get everybody back into proportion. Okay? So this is our algorithm for choosing which file to use. Now let's show you a small little example here, just so you can believe me. I will actually add a file to Tempdb. Okay. So I have this. Basically what I'm going to do is I'm going to go make Tempdb the original file 100 meg, and I'm going to add another 100 meg file to it, and then I'm going to restart SQL Server. Quick tip. I think I have this on another slide, but I'm going to tell you right now. If you add a file, you need to plan a restart. Does anybody know why? We calculate proportions, but that file is the most free file that exists now in Tempdb, and everybody's going to line up there. So if you add a file now that has nothing in it, then it's the most free file you have, and everybody's going to want to go to that file, right? Even though we recalculate our proportions at that time. So you want to get everything balanced again by restarting at some point. So I'll restart the service. What's the question? Yes. The question is if you have one file and you go to 8, okay. So the question is, if I go from one file to 8, do I have to restart because I got 7 free files? And the answer is no, probably not, because I got 7 free files now. But this one file that's pretty full, right? Yeah, won't be used. So yeah, if you're just adding a single file, though, if you had the opposite effect of 7 files adding to 8, then I would do a restart, right? So, okay. So now I want to bring in the use of this trace buffer that I talked about. There's no way I would ever expect anybody to try to interpret this query I wrote. If you're an XML shred expert, then be my guest, right? But basically, I'm taking down and I'm giving you in this script, when you get this from me, I'm giving you all the values of what's in this coded trace. So basically, there's something called an event number, and the event number tells you what kind of allocation operation it was. So if you first just dump this out, you see these numbers, you're like, what does that mean? Is that a GAM, SGAM, what is it? Well, I've got in the code here, when you get my scripts, you can actually debug what these are, right? So if I just first run this, it should be empty, because I haven't turned on the trace flag yet. So before I turn the trace flag, let me tell you what I'm going to do. I'm going to, I've got a procedure here that I'm using. Let's test temp proc that has a temporary table called Go Rangers. We are the Western Division champions. Yes, that's true. ALCS, I hope we do. Although I heard we're in a rain delay. And we'd definitely like to repeat, because we beat the Yankees last year. Any Yankees fans in here? Sorry, but we did beat you guys last year. And it was really sweet, too. I loved it. So, and then the Tigers beat you this year, which was even sweeter. So, okay, so let me go ahead and recreate this. Now, if you look carefully at my proc, what I've done is I've built this table so that anytime I insert a row, I've allocated a new page. So I put that as a parameter. So I can eventually run this proc and put in 7, and I'll get 7 pages, or put in 10 and get 10 pages, right? So let's do this. Let's turn on our tracing by this 1106 trace flag, and let's go run the proc. And we'll put a number in there. Let's say we'll put in 8 to do 8 pages. So I run this and it works. Now what does my trace look like now? Pretty interesting. I've got some data, and I've got this description. And what I wanted to show you here was the page IDs to prove that we switch. And if you look very closely here, you're going to see this alternation between 1 and 3 and 1 and 3. You see how I'm getting a new page each time? So I'm at page 1, I'm at file 1, then I go to file 3. File 1, file 3, and so forth. So they're both equally free, so I'm sitting here switching between each files. Now, in a very, very heavily used system, do not try to go interpret this output. I mean, this trace would be enormous. And in fact, it is a ring buffer, so you might miss entries. But for a very small test of what's going on in your app, you could use this to figure out, to see what the allocation pattern of what we're doing. Okay. Let's get back to our talk here. Okay. So, okay. Now, which file to use? So for uniform extents, you already have an extent that potentially has 3 pages, right? So from that perspective, you might be already using your extent first. But if not, to go get a new extent, we first use this choose a file algorithm, right, to go figure out which file. Then we go find a free extent and a GAM of that file, and we look at all the GAMs of that file. We don't switch. We don't like, okay, this GAM doesn't have a free extent, so I'm going to go switch to another file. I'm going to look for all the GAMs in that file, okay? If not, then I'm going to go find free extents in other files. So the switching algorithm works from find uniform extents in my file. If not, go to the next file, next file, next file. If not, grow, because I don't have any space at all, right? For mixed extents, and specifically for Tempdb, and I've got an article listed here, there was a change made in 2005, I think SP2 timeframe, in a CU, where we found that the switching algorithm we had was not efficient and was causing heavy SGAM contention. Because what we did was we'd choose a file, then we'd try to find a free mixed extent in the file. And if we didn't, we'd switch to the next file, instead of looking for other free mixed extents in that same file. This eventually led everybody to line up in one file. So we changed it so that we try to find a free mixed extent in the current file. If not, we try to allocate a mixed extent in that same file, and then we start switching files. So for uniform and free, the algorithms are now aligned, because before they weren't. The mixed extent algorithm was slightly different. But this is unique to Tempdb. We don't use this algorithm for mixed extent allocation in user databases. So we do support the ability to switch to a file and then make smart decisions within our file, so we don't do heavy switching back and forth. And if you get a large number of files, that can be pretty expensive. Don't forget about deallocation. I talked about everything. You know, in a perfect world, if you're just allocating the whole time, this probably balances out really well. But we talked about in Tempdb how you have to deallocate frequently, depending on your usage. So for deallocation, it puts special pressure here. Any page deallocation requires us to touch the PFS. We've got to mark the fact that we don't need that page anymore. A page deallocation may lead us to deallocate extents. Well, what does that cause? We've got to update GAMs, right, for uniforms. Or for mixed extents, we've got to update potentially GAM and SGAM, right? Truncation can involve page and extent deallocation, except for cache temp tables. We talked about the fact that we're going to keep around an IM page and one page for your heap, and for a non-clustered index on that cache temp table, we'll even keep around a page and the IM page for the non-clustered index. And then deferred drop can help because of the fact that we don't, let's say I talked about the case that temp table caching only works for tables less than 8 meg. Okay? Greater than 8 meg, we still cache the system table entries, but we don't keep around those pages, the IM page and the single page. So, but we do a deferred drop for those pages. It's not an immediate operation for when we do drop a temporary table. It's done as a system task background operation. That's no different than your user databases when you drop or truncate. But a lot of these could build up. I mean, I've seen this before where I'm doing a lot of operations on temporary tables that are very large, and they get auto-dropped. And so I don't see a lot of contention, but then I start inserting new temp table operations, and they get blocked all of a sudden, or they get contention from a bunch of heavy deferred drops that the system decides to do. So deferred drops are nice, but it doesn't necessarily mean you're free totally from contention. And then here's the ultimate collision scenario we're running into, right? Of everything I've just taught you in these principles, and I remember all the little triangles I highlighted for PFS, for GAM, for SGAM. All of these things together can run to a collision. There's massive pressure on these 3 pages to do all these operations, right? Frequent create and drop of temp tables, internal object allocation and deallocation. And then there is also a scenario for heaps where, depending on the amount of space you're actually using the heap, we may have to go back and update the PFS to record the amount of space used on that page. So a lot of pressure there. And what are the symptoms of this great collision? Well, you've seen them, and it's been blogged about by 1 million people, and that is page latch waits. And you usually see them how? You see a database ID of 2, some file ID, and then some fixed page number. What do I mean by fixed page number? Well, it's based on the PFS, the GAM or the SGAM intervals, right? They're not page latch IO waits. It is certainly true that you can get page latch IO waits in Tempdb like any database, right? Depending on disk latency. But I'm not talking about that scenario here. I'm specifically talking about the fact that we have to latch allocation pages to search on them, to find information on them, and to make changes to them. And so what do you do about it? Well, certainly today I've hammered home the need to do temp table caching. I hope I've demonstrated to you the differences in the logging alone and the system table, the different things we do with system tables to avoid contention there, and also the reduction in allocation. Trace flag 118, I'm going to make a case for that on the next slide here. Multiple data files, and we talked about doing a restart. Prevent auto-grow. Auto-grow scenarios can certainly cause problems here. There's even a trace flag to help you allow an auto-grow on a file to make all files auto-grow equally the same. But be careful, okay? Be careful. That is a server-wide trace flag. So that happens to any database, not just Tempdb. And then second of all, you don't want to do auto-grow anyways. Large auto-grows can take time. So if you have to grow all of them at the same time, this could be pretty bad. The question is, do we plan to make this trace flag specific to Tempdb? And the answer is, not that I'm aware of. I suppose if I started asking for it, we might could, but I haven't asked for it. So. And then find out what's consuming internal objects. I think a lot of people I talk to can get a pretty good feel for their temporary table and table vary usage, and then got a handle on that. They can do configuration of what we talked about to get a better solution for running into contention. But what usually throws them is this internal object usage, sorts, work files, work tables, version store, all those things, which really throws most customers I run into from properly getting a handle on this problem. And I've told you, it's not easy. There's a lot of different ways that they're used, but I gave you a lot of information in these slides about how to go track those things. So now you see the big problem here. Here's the case for trace flag 118. We create a new temp table with a few pages. So we use a cached IM, we use a first cache page, but if you're using mixed extents, this next page you may need to come from a different mixed extent or even a new mixed extent. Okay? Truncate could potentially have to deallocate the new mixed extent that you had, right? And the cat page we have for caching is in a mixed extent. Excuse me. So there's a lot of operations that are required for mixed extents in general that are a little bit, in my opinion, sometimes unnecessary. Trace flag 118, which again is a server-wide trace flag though, what it says is that don't use mixed extents. It says when we go create allocation for this table for a non-IM page, then use a uniform extent. Now think about what can happen here. In the case of temp table caching, we get to use the cached IM page, right? I told you we cached the IM page. The first cache page that we have is part of a uniform extent. So that extent stays around. So effectively, we've cached a uniform extent for your table. So if you were creating a temporary table that only had 8 pages, why would you use this? Because you basically get to go, you get to avoid an extent allocation operation for your table. Now, it's possible for mixed extents that you could as well, but you don't control that because they're shared, right? So it's conceivable when you're creating a table with mixed extents that you could get lucky and that your 8 pages you have could show up on a free mixed extent and you don't need a new one. But then you don't control what everybody else is doing, right? With uniform extents, it's yours. It's cached. It stays yours. And so you get to avoid, in a lot of cases, extent allocation. Let me just show you. And this time, let's see here. Yeah, let's go back to the examples we were working with. And let's look at the logging differences using this trace flag. So remember the examples I had up here. We can just use, in this particular case, we will use that caching. So I'm going to restart the server so I can clear that cache. So I've got this trace flag ready to go here so we can use it. So when I was using this proc right here, and I'm going to run it again for 8 pages. Oops. And I'm going to look at the tracing. Oh, I didn't set my tracing up, did I? That's okay. I want to cache it anyways. So I'll set my tracing up for that allocation cache. I'll run my query to get 8 pages, and then I'll look at my cache. And if you look at this, remember how we were bouncing around for different pages? And if you see the numbers here, you'll notice there are not a lot of consecutive pages that are being used in a given file sequence. If you go in and turn on this trace flag now, though, and I think I was at what? Record 26 here. Okay, I'll run this again. So starting from 26, from 27, notice the difference here. Do you see how now I've got a consecutive use of pages because these are all being part of a uniform extent? And I avoid any possible new extent allocation for mixed extents. Like again, if I had a particular page that I needed for this table, one of the 8 pages, and there wasn't a free mixed extent, I've got to go allocate a new one, which requires SCAM access, right? With trace flag 118, there's never a need for SCAM access, except for one condition. Does anybody know what that is? So 118, I just said, we use uniform extents, right? I created 8 pages, I need a uniform extent, no problem. If my temp table is not cached, I still have to create an IM page, right? So if you don't have a cached temp table, I need an IM page. That always comes from a mixed extent. It never comes from a uniform extent, even with the trace flag on. But I can radically reduce, potentially, the number of extent allocations required by using the trace flag. And I've got data to prove it later in the talk. The question is what? Creating a clustered index on the temp table to avoid a mixed extent? That's correct. Absolutely. Okay. So let's talk first about system table page contention. Then we're going to get into about the how many file question. So, so create drop operations we talked about require system table changes. You may see more allocation on you may see more contention on these pages after you've kind of resolved your allocation page problems. If you've resolved your allocation page problems, let's say that you've done multiple files, you've done various types of things, and you don't see much contention there, what you might start seeing is contention on different page numbers in Tempdb that you're not aware of. Sometimes they end up being the same depending on how much allocations occurred. But you're like, what are these pages? You go look at them and you say, oh, it's object ID 34 or 40 or something. Those are system tables, right? So what I've noticed is that people get out of the page allocation contention problem, they start running into system table page problems. But as we've seen, caching can make a difference. And then if you've got long transactions involving user tables, you might start having locking problems on these tables because we have to keep them locked during these operations. Table variables, though, as we said earlier, are not affected by that because of the fact that we don't support rollback. So user transactions don't hold open locks for table variables. But remember about caching. Caching really makes a difference. There are some limits and restrictions. We talked about that. And I talked about a change we have to make. We have to, even for caching, because we have to flip back and forth between this long name with underscores and a cache name with that hexadecimal value I showed you, we change the name. Well, that name is stored in a system table called sys.schobjas, which is object ID 34. So what you might start seeing is some contention, when you've resolved everything else with caching, contention on pages with that object ID. And you're saying, how do I get rid of that? You're going to call me up. I'm going to go like, sorry. Because of, even with caching, we have to go change that name back and forth. There's going to have to be some modifications to that page. And that's not avoidable. That's at this point, a point in time with the design of the engine, that is unavoidable. System page allocation, though, one thing to point you out is that can be spread across multiple files. It's only the primary file group it's related to, not just the primary file. You can see it yourself by going and doing heavy allocation and finding that object ID spread across other files. So sometimes the page number that comes up is not file ID 1 from these system tables, but file ID 4 or something like that. And then here's a very important point. We'll talk about it a little bit. If you use that unique constraint concept I talked about, that adds an additional burden of recording an entry in this system table, sys multi-obj refs. So if you use unique constraints, we have to record something there, and if we have to get rid of it or remove it, then we've got contention potentially on pages for that table. Just a review about internal objects and allocations about how they're involved. They all support that whole round-robin proportional fill algorithm. System tables are not required, even for work tables. But we do have to log allocations in some cases. In the case of work files and version store, we don't even do that at all. We don't have to log anything. And you can see here, everybody uses uniform extents except for work tables can use mixed extents. And that trace flag 118 can affect work tables. If you use trace flag 118, a work table is created by the engine would actually use the uniform extent for its purposes. So, we're finally here. We're finally at the part of the talk where it all comes down to this. I told you at the very beginning I would tell you exactly how many files you need. We're finally here. And the answer is 8. No, it's really 16. No, it's 32. Actually, it's the number of CPUs. That's really the answer I'm looking for, actually. No, it's really half the number of CPUs. And I saw him walk in the audience here, so he's going to get really mad. Only Paul Randall really knows the answer to this question. No, I'm just kidding, Paul. Actually, he's got some really good blog posts about how this works. No one really knows, actually, in my opinion, exactly. And if you actually know the answer to this question and can demonstrate it time and time again with every app in the world, I absolutely want to hire you. Okay? I will make this comment, though. If you have more than one user and more than one CPU, it's not one. Okay? I actually have some data to show you on a benchmark I did to give you some feel for this. So, here's the problem you deal with when we're dealing with this question. What is a standard Tempdb workload? Can anybody show me what that really looks like? Look at all the stuff we put into Tempdb. What is a standard workload for this? That's one of the biggest problems I see. How do we create some sort of benchmark for this, right? Now, I've got a crude benchmark based on something I did, but I mean, it's really hard to pinpoint exactly the usage that's going to predict for you what is the right number of files. There's so much stuff that goes in there. And there must be a cost to switching. If you put 5,000 files out there, and I told you the algorithm is to have switched between these files, that's CPU cycles to make those decisions. And then we've got to calculate the proportional fill for the files. There has to be some sort of innate cost to do too many switching, right? And then, and this is something Paul did point in his blog very, very well, if you've got so many different files out there and we have to start flushing potentially pages from them, you could potentially end up doing random I/O on the disk. And if that disk matters, in the case of Tempdb, it could matter, right? It could be potentially expensive. So this is not an easy problem to solve. Everybody wants to know exactly that number. And why is it so hard to solve? Well, these are the kind of things we think about when we're trying to solve this answer. So I do have a crude benchmark that I did. I picked a machine in one of our lab environments running Windows Server 2008 R2 and SQL 2008 R2 Enterprise Edition. It has 4 8-core CPUs hyper-threaded, so 64 logical CPUs, 1 physical disk, and 128 gig of RAM. What I did is I created a procedure. You've already seen the procedure. Remember the procedure that creates with a page count variable, it creates 1 page effectively for each row? I used that procedure. I ran that procedure 100 times with 500 users using our ostress utility, which just simulates 500 threads. You know, it uses 500 threads to simulate 500 users. I ran it 100 times in a loop, right? Everyone runs at the same time. So you just kick it off and run it 100 times loop as fast as you can. And all the proc does is just create and populate a 64K simple temp table as fast as it can. And I ensured that the tables were cached. because I thought that was an important principle I've just talked to you guys about. I didn't want to not do caching because I just introduced all sorts of other things as part of the test. So I ensured they were cached. I looked at the caching to make sure it was working, and I ran this test. And I make sure there's no auto-grow. So any files that I created were 100 megabyte, and before I started getting to the actual benchmark, I observed and ensured there was no auto-grow occurred, and I created a log of 500 meg just to make sure I had no log auto-grow or anything of that nature. Okay? So when I did this, these were my results. If you look very, very closely here, at one file with trace flag 118 on, it took 8 minutes. When I had one file with it off, it took 18 minutes. So I'm sorry, but if you only have one file, I've just made the case for the trace flag right there, in my opinion. I mean, 10 minutes shaving off, right, just by using the trace flag. Again, a simple benchmark, but that's a pretty good case. Now look what happens when I go to 8 files on a 64-way box. I go down to 38 seconds. From 8 minutes to 38 seconds, or from 18 minutes to 45 seconds. So I've just made a case really big time that on a machine with greater than 8 CPUs, you should use 8 at minimum, right? I mean, there's no question in your mind from looking at this data with a simple benchmark that it wouldn't be wise to do that. But this is what I thought you might find interesting. Look at the numbers as you get progressively larger. You go to 32, it does reduce the time in half, but it's beginning progressively less. And if you go to 64, there was no difference. Went to 64 files, and I didn't see you can see I got a 2-second gain for mixed extents, right? But I didn't get much gain. I didn't get any gain at all for uniform extents. And in fact, in some cases on the test, when I ran with 64 files, the uniform extent algorithm kind of started getting worse a little bit. Now, I did no study here of what kind of contention I was getting. I didn't look to see whether I was getting heavy contention on PFS, GAM, whatever it was. I didn't even do those kind of measurements. Maybe I will at some point. But I thought you might find a very interesting, small little crude benchmark that, in my mind, kind of sold me the fact that I at least need 8, and I might consider going to 32, which kind of lines up with the half CPU type algorithm. Now, is this going to mean that you should walk out here and go I need 8, I need 32, I need 64? No, but it gives you some gauge of what might be possible depending on a kind of a standard type of Tempdb workload. The workload is creating a cached temp table about 8 pages in size. And that's all I'm doing is pop. Remember, who creates a procedure with a cached temp table of 8 pages, and that's all they do? You do something with it, right? So, I mean, I was hammering contention on allocation and system table pages as fast as I possibly could, when in reality, you usually do some sort of other operation within your procedure. So what's my advice? If you have less than 8 CPUs, you should probably go to 1 file per CPU. You might even go to 8, even if you don't have 8 CPUs. I've certainly seen that before. And the trace flag, I think, absolutely makes a big difference. You can see in the 1 file case where I reduced the time by 10 minutes just by turning on that trace flag, proving my case about the reduction in for allocation page contention because of the uniform extent concept. I'm dedicating uniform extents to my tables. If you have greater than 8 CPUs, I'd say start with 8. Look at the test I just did. Start with 8, and then monitor your application for page latch contention at that point. Expand maybe in units of 4 files and keep monitoring in those kind of type sequences to see what is the threshold you need. I think I just showed you my little crude benchmark that 64 really didn't help. Why go to that case in this case of 64 CPUs? Think in the case in terms of 256 CPUs. Probably you start running into these problems of file switching and potentially random I/O. But I have had this. If you call me up in an emergency and you have major page latch contention, I may tell you to go to number of CPUs. I don't know. If we have to make a quick decision, we don't have time to go test this all out, I may go to that kind of level. Yes, sir, you have a question? These are logical CPUs. So it could be, I have hyper-threaded cores in my case, right? I had 4 8-core processors that were hyper-threaded. That's how I got to 64. 100 meg. Again, I wanted to avoid auto-grow. They didn't have to be 100 meg. I just picked 100 meg because I knew it all fit. Could be less. Don't rely on auto-grow. Yes? One physical drive. One physical drive. No I/O latency problems with this test. Okay, so that's my root. Yes? I'm sorry? Well, first of all, Hyper-V, you can't have that many CPUs, right? So, you have 64? Okay. I don't think virtualization to me matters in this case, right? So I suppose virtualization could matter in how fast you can context switch among threads on virtualized CPUs, but to me, I don't think this matters for virtualization. At least I didn't do any virtualization. This wasn't a virtualized machine, by the way. This was actually a bare metal machine. You have a question? Last question about this, and then I'll take more questions at the end about it.
What about different editions?
Yeah, I used Enterprise Edition, but from my understanding how this code works, I don't think there would be a difference from standard and Enterprise in this case. Okay, let me take more questions this topic at the end. Let me move on with the rest of the slides, and I think 4:30 is our stopping time. I think we have plenty of time to get the last questions in. Okay, so a couple of notes about kind of management troubleshooting type things. So who in this room has actually worked on SQL Server 4.21? Oh my gosh, really? Kim, I see her back there. Yeah, okay, 4.21, I'm impressed. Do you remember an option called Tempdb and RAM? I get that question like every year. Somebody comes in and goes like, how come you don't put that Tempdb and RAM thing back in? Well, here's why. Most Tempdb pages are already cached in the buffer pool anyways. Why do we need to do that? Work tables are just like user tables, so they're cached as well, just like temporary tables and user tables. And we don't normally checkpoint Tempdb, so these pages may be running cache longer. And then the last point, sorts and work files, they're already in memory. They're a memory concept. They just use Tempdb for paging operations. So I suppose we could do paging and cache, but that doesn't make a lot of sense. So I get this question all the time, and my whole thinking here is that Tempdb and RAM doesn't make a lot of sense because a lot of stuff is cached already. Now, maybe a solid-state disk makes sense. That's possible. But certainly trying to create some special Tempdb and cache, in my opinion, doesn't really make a lot of sense, and that's why we took the feature out, actually. Tempdb growth, you might find this a little bit interesting. So I had people ask a lot of time, why does the log grow out of control? You may have a scenario I have not thought of or seen, but these are the two I run into. One is an open transaction, but remember, it only makes sense for temp table and user tables. All the other stuff we talked about, the logging and the transactions that work, they're very short-lived. And in the case of table variables, user transactions don't even affect it. So if you've got an open tran type scenario, it's probably some temporary table or even potentially a user table. Okay? That's causing truncation not to work. Or there's some issue with the truncation code, which is done by checkpoint. Now, typically it's around 70% full, just kind of like a simple database that we choose through this truncation. That's my observation. I didn't go prove it in the code, the exact algorithm, but that's my observation. And so I have seen some cases where checkpoint is not kicking in because that's what's responsible for doing the truncation. What about the data file? Well, what I've seen before is people, can you wait for your question at the end, please? What's that? Can you reserve your comment for the end? Thank you. Unexpected temp table input. So I've seen customers that will feed a temp table from a select into or feed it some other way, and that input changes. Oh, things were going great, and then the data file got way out of control. Well, it's probably because the input into your temp tables changed, or your table variables. And then work tables or work files are kicking in, and you don't realize it's happening. You've turned on some feature, or there's some sort of memory pressure, something with query memory, with sorts, with hashes, that is causing unexpected use of the data file for Tempdb. Massive sorts may be going on. And there's some sort of version store explosion. Literally, I did have a customer turn on recommitted snapshot isolation. They call us and say, Tempdb just started going nowhere, out of control. We're like, yeah, that's normal. You put on the snapshot isolation feature, we're going to need temporary space. Some other comments about Tempdb, specifically about shrink. This is going to surprise you, and I didn't even know this until I started doing this talk. But if you go to Management Studio and you go into Tempdb and you try to change from 100 to 5, we run shrink file. We don't do alter database, change size to 5. We actually do a shrink file operation, and that may not work. Okay? But an alter database changing to 5 will succeed and then kick in when you restart the server. So kind of be careful of that one. You can't shrink internal objects. So the shrinking algorithm may not work for you as you expect because of this internal object usage going on and extent allocation from internal objects. And shrink's not working as you expected because they're being used and it can't be shrunk. We don't support them in the shrink operation. And then you can't do auto shrink. That's not supported. So when you're moving Tempdb, you may have seen this before, but you can simply make alter database commands to move it to a new location. On restart will take effect. When you remove a Tempdb file, if it's not empty, you'll get an error saying, "Hey, you can't remove this. It's not empty." But that's okay if you just want it removed for restart, because in restart we actually get rid of the file because we recreate it. Same thing, same kind of concept for adding files. We talked about doing a restart. So some interesting things about CheckDB. So there's an implicit with tab lock when you use CheckDB with Tempdb, okay? You don't even realize that. You don't have to do with tab lock, and we implicitly do that. We don't support database snapshots for this, so we can't do an online CheckDB. And then we don't support checkalloc or check catalog. You run CheckDB, you don't even know that's going on really, but if you run checkalloc or check catalog separately, you'll see you get an error back. So the only thing we do to check the consistency of Tempdb is run a check table on all the tables in the database, and that includes your temporary tables, or the cache temp tables that we have, or any user tables you have in there. And then you can't run repair. Doesn't make sense to run repair. You can't put it in single user mode anyway, so there's no way to actually run the operation. But we do support checksumming. So that's one thing that we added in the server. And in fact, in 2008, that was a change that was made to turn that option on by default for Tempdb. So checksumming of all these types of pages is supported for Tempdb. What about, so the last slide over here, and then we'll have time for your questions. What kind of issues does CSS run into? Well, the common issues are the ones that we've talked about today. There's no question the number one topic that comes into calls for us is page latch waits, both on allocation pages and on system table pages. If I had to go look through all the cases we have even over the last year, 90% of them dominate this type of problem. But we do have unexplained growth questions that come in. Somebody says, look, Tempdb log is growing out of control, or the Tempdb database data files are growing out of control, and I don't know what's going on. And then we start getting this discussion of what I just told you to figure out what they're doing. And then we have page latch I/O wait questions come in. And so I've definitely seen this before where customers will call us. Their problem is performance issues. They look at the file number and the page number in the wait resource. It says Tempdb, and they think they got to add a bunch of files. And then I'll look at the wait type, and it says page latch I/O. And so I explain to them that has nothing to do with system page allocation contention. That's just latency going on with actually reading or writing to the Tempdb database. So when you see page latch I/O waits, think in terms of disk latency. It has nothing to do with the system allocation page contention we talked about. And then there's a small little table I built here of some issues we run into over the last couple of years, and specifically even some recently, where there's some unexplained contention you might run into. The first one deals with the sys multi-obs refs system table. And this is a problem that was reported on the MVP alias and then by another customer. And as it turns out that in the second row here, I'll talk about some reasons why you actually legitimately might get contention on that table. But we actually found a small bug in the product where we're actually going after a latch on that table when we shouldn't be. And so I listed actually if you put on SQL 2008 R2 CU9, there's actually a fix that goes along with reducing a latch on that table that's never needed, okay? But there are reasons to actually put things into that table. I mentioned one already, unique constraints, right? Unique constraints, filtered indexes, objects that reference multiple objects like a type, like if you created a type and then reference it in your temp tables, we'll have to put entries in this sys multi-obs refs table. So when you're going through and creating and dropping those tables that reference that, guess what? We have to go after that system table, okay? So be careful on those. You might run into contention on that system table. You don't realize it. The use of OpenXML has caused some problems. And then I've seen some yielding issues. Bob Taylor here is in the audience, and this is a specific case that we worked on together, where customer was actually running into a kind of a schedule yielding problem because of the use of temporary tables in ad hoc batches. It was actually prepared batches. So they prepared these statements, and they were preparing the actual access, the insert commands and so forth that access the temporary tables. Well, the way we do hashing in the procedure cache caused a massive yielding problem. So we created a fix for this so that while your procedure cache may get a little bit larger, the performance of actually looking up the cached plans for these ad hoc prepared statements was dramatically different. It created a dramatic difference for us. In this particular case, if we had gone to stored procedures, we'd never had the problem. So those are just a couple of common issues we see in CSS and some other more obscure problems you might run into. So a couple of resources I thought you might find interesting. There's no question that if you had to walk away today, besides the talk we have here, and say, what is one thing I can read to learn just about everything I want to know about Tempdb? It's this white paper in the beginning. This white paper was written for SQL 2005, but much of it still applies to what we have in the product. Please go read that. In Paul Randall's blog, he's got a really good section. If you go to his blog and pick Tempdb, he's just got a laundry list of all these links that you can read, both the things that he's written and other people on the dev team have written about Tempdb. And then finally, the SQL Storage Engine team has some great posts as well on Tempdb. And those are resources I use in my talk as well. to put some of this information. A lot of times I use those resources to confirm what I was running into is actually accurate. I would do some tests going, hey, that didn't make a lot of sense, and I'd go read these to see whether it lined up with what other people are thinking. So we have actually plenty of time to ask a lot of questions. So let me stop right now and see what other questions you have. Yes. Can you, if you do me a favor to help out, can you stand up and really speak loud? There's no mic in here, I guess, so. What is the exact difference between caching a temp table that has 8 pages or more than 8 pages? So it's not 8 pages, it's 8 megabytes. So if a temporary table has less than 8 megabytes of storage, we will keep around the IM page and one data page effectively. If it has greater than 8 meg, we will not keep those around. Yeah, I know how to. Yeah, I can answer that. So the question is, how does this temporary table cache work with multiple users effectively, right? Well, with the same plan, same proc plan. Effectively the temporary table cache is tied to the procedure plan. But when it's in use, it can't be reused by somebody else because it's a table. So you'll effectively get a new one. But if you have, say, 100 users running the same procedure, you'll build up 100 of these cached temporary tables, right? And then now they can be reused by 100 different people, if that makes sense. So yes, 2 people can't use the same cached temp table at the same time for the same plan. If you think about it, it's an actual table, so there's no way we could actually have somebody use the same thing, right? It's a unique table to that session. Yes. So the question is, do you use the advantage of temp table caching if you use ad hoc SQL? And the answer is yes. We only support temporary table caching when you use temporary tables in procedures, function, and triggers. And the reason is, you can't cache a create table #X statement, which is in the ad hoc query. So how do we do the caching if we can't cache the create table statement itself? There's no way to support that. Same thing for a dynamic SQL statement, like an SP execute SQL command. By the way, as you're walking out, please fill out the evaluations, but I'll still stay here to answer questions. Could you please stand up? The question about 8 CPUs and 8 data files. You mean on the benchmark I did? Yeah, log files are the same type of consideration you'd have with a user database. I mean, so there's no difference there in planning. But just remember, there's a lot less logging going on than a user database. But that's no different of a discussion than just doing logging and planning out a different number of files for a user database. Sorry, here in the front.
I was just wondering, like maybe in SQL 2016.
So the question is, in SQL 20 whatever, would we ever consider creating a temporary database for each user database? I know that I've personally asked for that type of feature before. I will tell you one thing, I don't know the answer to that question, but I will tell you one thing. One great benefit of doing some of these talks is I have a lot of valuable feedback from the product team. And I found several things out of this diving into the algorithm that I think can be improved. A lot of them I think they know. It's just a matter of, can it be done in lieu with all the work that they're doing. But I don't know of any plans to do that anytime soon. Yes, sir. Yes. You mean, so the question is that in terms of system page allocation, is 4 gigabyte the right size because of the fact that's a GAM interval or an SGAM interval? So the one thing we don't do, if you think about this, we don't spread out and we don't switch between intervals in a round-robin fashion. Okay? However, if you do temp table caching, its potential, right, your uniform extents are on different intervals. And that actually influences the target we go after for getting new uniform extents, right? But we don't, just like we switch files, we don't do a switching across intervals. We don't spread out the allocation across intervals. So even if you created a file that says 8 gig, it's not like we're going to go after and start using other GAM intervals because we're going to switch back and forth between them. That's not how it works. It could have some benefit, But I'm suggesting that just by doing that alone, I don't think it's going to just decrease your contention. You would be better off having the multiple file concept of that smaller size. Does that answer what you're asking for, maybe? Okay. Yes, sir. Yes, trace flag 1117 is a trace flag if you turn on a server-wide trace flag, not Tempdb, that when we auto-grow all the files in that file group equally. We grow them all that same, which is why having auto-grow, we just do a grow, right? And we auto-grow all of them based on their auto-grow properties. So auto-grow should be set to the same, right, for Tempdb. But you got to be really careful with that. So I want to make a point about that trace flag. So I'm just telling you that if you're going to have auto-grow in your system, that's not a bad thing to have, right? It is server-wide, but to auto-grow could be very expensive now to do this operation. And while I think auto-grow is an amazing feature, it avoided, when we introduced it, reduced the number of pages I got in the middle of the night. Yes, I had a pager back then. You know, I don't think it's a feature you should ever rely on as a normal part of your operation. It's more of an emergency feature so you don't run out of space. So I'm just pointing out that trace flag, but I'd be very careful about whether you use that or not. No, it's zero. For the log, it has to zero it out, right? You know, that's a great question. I'm not sure the answer to that question. I'll have to go look it up. I think it's a data file only feature, but I'm not sure. I think it's data file only. So if you didn't have instant file initialization turned on, then we'd have to zero out those files, right? Data only. There's your answer. Next question. Yes.
Would you recommend using Tempdb for staging? Get a lot of data from other databases, Oracle, to put all this data fast in SQL Server to then work. Would you recommend using Tempdb for staging?
Well, it's faster, but I mentioned it doesn't support crash recovery. So if you care about that data, the answer is no. Well, if you don't care about the data, then why not? But you are putting, by the way, you're putting increased contention now in that database with everything else you're doing. So that's a trade-off, right? Yes. No, that's all right. No, I think that's it's good practice anyways. I mean, I don't think it matters just because we log less. We still have to log. I showed you all the different things we have to log in there, right? So I would. Yeah, absolutely. Yes. Oh, did I have a slideware problem? So 1106 is for the allocation ring buffer tracing. 1165 is to dump out tracing of our proportional fill algorithm. There are two different trace flags. Yeah. Yes. So I made a comment there earlier in the slide. I was surprised by this, but it doesn't, actually. So I've done tests where I've done a create proc, I've created a temporary table, I do a drop of that temp table, and I still get caching. So it is a DDL, but it still supports the cache. Now, I don't know if there's a version change with that. I didn't do the research to see whether we made a change to support that. One of my colleagues was surprised that worked as well, so it could have been different from a previous version. I mean, by the way, I don't think you get any benefit from that, so I'm not sure why you would do it anyways. No. That's hard-coded within the engine. The question is, can you apply it to tables larger than A and B? Remember, though, we still cache the system table entries for those. The caching I'm talking about for the greater than MB is saving off the IM page and the first page, right? Yes? CheckDB does use Tempdb for work tables. We talked about that. There have been reports of estimate only having problems, yes. I think the only thing you could do, remember work tables end up actually using the internal object counter from sys DMVs file space usage. You could monitor that while you're running CheckDB to see how much it actually used in terms of pages. Yes? Is there any plans to have resource monitor change, better be careful there, to avoid its Tempdb usage? I've never studied how much it uses. You're talking about the activity monitor? Oh, what resource monitor are you referring to? Resource governor. I'm like, okay, I'm not sure about resource governor's use of Tempdb? Oh, use it as a quota for Tempdb. I'm not aware of any plans to include Tempdb throttling for resource governor. I've not heard of those plans for that. Yes? I think that was kind of asked a little bit earlier. Are you asking for like your separate Tempdb per database? Okay. Yeah. Yeah, you want to know, can I have my own user database without using Tempdb contention to do what, and I'm not aware of any plans to do anything like that. You could do bulk logging, though, obviously, which reduces log space, but other questions? Yes. Yes. I think that's what he was just asking. I'm sorry, I didn't repeat his question, but I think he was asking for exactly what you're talking about. A user database that has minimal logging and everything else. Is that what you're trying to? Yeah, I'm not aware of any plans to create such a feature. Okay, well, thank you so much. Oh, one more question, sorry. Back there. Wait, is there two people talking? Okay, because man, I must be going crazy, dude. Go ahead. You right there, standing up. The trace flag is not edition specific. You can use it in any edition. No rollback support for them. That's right. Okay. Okay. I'm not sure what your question is. I'm sorry. Can you bring that scenario up to me afterwards? So, any other questions in the audience? Thank you so much for your time today. I appreciate it. Have a great time the rest of the conference. Thank you.